I love cast. There's Nerd Soul. Wait, am I streaming on the correct channel? Hold on. Yeah, I think I am. Alright. It's weird sometimes, you know, when you stream on multiple. Alright, we need to go into the streamer mode. Streamer mode. Like this. And then I do this. Alright, is there like a better way to do this? So basically I want the window over here always. How do like other streamers do this? Like the is this usually done with like an overlay? Like the way I'm doing this is I'm making sure that on my like screen this like right part is actually not being used, and then I'm having this window here so that I can just work on it. Search Coovy on Twitch and it's set to follow Doovy. Wait, what's Doovy? Who's Doovy? Doovy. Right, what date it is? 22 of May. Today is the day. Alright. Who's third alter ego? Is this actually something? That 32 followers. Did you follow the Doovy from your 32 accounts at the same time, Badcop? Alright. Okay, what's happening? Okay, hold on. I also need this to be like pinned so that it stays on all the workspaces. Like so. It's you, self-promo. Right, we're working on cast today, of course. What else are we going to work on? We're not going to work on Linksider, right? Linksider is basically done. We're just waiting for everyone to wishlist the game. So if you haven't, wishlist the game over there right now. You have mononucleosis. Nucleosis. Is nucleosis something which is like nuclear? What does that mean? The kissing disease? While I'm researching. Did you see a doctor? Wait, how does it translate? Maybe I know what it is. No, I don't know what it is. I know, is it supposed to like go away on its own? Or what? Is it? Or no? I don't think I heard about this before. just go away like other viruses. All right, well, then you just need to wait, I guess, Betkov. All right. Are you going to get back to streaming once you are recovered? Right? Okay, I did something off stream. What did I do? What did I do? Nothing useful, I think. Let me see. Git log. Just made something. Nothing useful. Just like some small refactoring, moving things into modules. Don't worry about it. Nothing actually happened. Okay, what are we going to do though? I don't really have a plan. I think we might go off stream, cheater. Well, you see, like I have work now, and you know how work goes. Just sometimes need to take a break from it. Did you miss a clippable moment? Yeah, I don't know. I'm not really focusing on like generating clippable moments on stream. Should I? Is that how you stream? Before, like, that's why you are not streaming for a long time, right? You're like trying to plan your next stream for maximum clippiness, right? That's what you're optimizing for. Maybe I should think about it more. It would help grow the viewership, right? All right. Anyway, we made this example last time. Look at this, Bedcop. So what's happening here? I'm making a macro, right? So this is a macro. Macro is a thing that is generating code. So over here, just like in Rust, we call a macro with this as an argument. So this argument here is just like in Rust, has been passed like this is not the value. This is like the AST. I mean, in Rust, you're being passed the tokens. Well, I'm passing the AST directly as the argument to the macro, and then based on this AST, I'm generating code. And this is not just like a declarative macro. This is more like procedural macro of Rust, where we can have some any code here. The code is 2 pixels. Is my like thing not big enough? Is the font? How do I even increase the font in Vim? I have no idea. You know what? Maybe today is the VS Code day. What is this, Zeng? The last thing that I worked here in VS Code was when I was doing Zig. Really? VS Code flashbangs when it opens? Wait, does it? Wait, what? Where is it? What do you mean by flashbangs? There is no... Or did it do it on the first? It did? Alright, I don't know. Didn't see it. What is that? Deprecated extension. PostgreSQL is going to be deleted. Maybe. I don't know. What else? Update code. Oh shit, I haven't updated my system in a while, right? What is this? Oh, this is just a file with comments. There is nothing in it, just comments. Lol. Whose idea was that? All right. Yeah. So this example over here, we have a macro, and this is basically a proc macro in Rust where we can run any code while generating code, right? But unlike Rust, we can also inspect the types. We have the inspection. I mean, not inspection, but I can... I guess, yeah, it's not like exactly inspection, but we do have the type of, and I can do this, which Rust cannot do. So it's Rust, but better, yeah. I think this example is kind of nice. The only thing I would like to change this to something else. It's a little weird. So what I'm doing here is I'm doing eval AST type of body. So like we have the body as the AST, right? So I need to compile the AST into something else, right? So I'm compiling this into this code, which is type of body, and then I'm trying to see what it is I'm evaluating. I mean, I guess it makes sense, but it's a little weird. But also, I guess if you are doing the code generation based on like type inspection, then you don't even pass the AST as the body, but you instead just pass the type itself. Like if I want to generate code based on the type of X, I should just like have the type of X here directly, right? And this should be not the AST. This should be just treated as a type, right? So this should be a type and not AST directly, maybe. But that means that it's no longer... So like macros are the things that are not only outputting ASTs, they're also having ASTs as inputs. Right? Yeah. But we sometimes want to just output the AST with having the input being something else. We can do that already. I'm just wondering if we should have a different syntax. So like I can construct the AST here directly, right? Let y be 1, 2, 3, and I can like compile AST here. I think that's how it works, right? dbgy. Like it should print 1, 2, 3 here. Yeah. Yeah, it's printing 1, 2, 3. So like this is the code in the form of the AST, and then I can just inject it into the current code, which I think should be not compile AST. I think we should be renaming things. This is more like include AST. So like if I have the AST and I want to just include it in the current source code as is, then we just do this. It's similar to including a file, but I'm including the AST, right? Yeah, let's just rename things. Maybe we go renaming things today. We love renaming things. We love thinking about syntax and thinking about naming of things. Oh yeah. So I like there are a couple of us other streamers that I know who are making their language. So there was like, I don't know if you know Lane is making the language, and there was basically the question whether the unit type and the unit type is the same thing. So so this I mean not the unit type. This is an empty tuple. So there is like empty tuple, and then there is the unit type. Should they be the same thing, or should they be the other things? So usually, like in Rust, we say unit with the like opening closing bracket, which is like an empty tuple, and the empty tuple is like supposedly also the same thing. So should they be the same, or should they not be the same? Right? That's the question. Whichever way avoids that Python bug. What's the Python bug? Can you support bash style aliases? What's bash style aliases? Isn't bash alias just a function? I mean, you have like alias ls, alias l is like, you know, ls la. Like that's how I do it myself, right? which is basically like a function. So you have like function L, which is a function which does ls la, right? Whatever. Like I guess the problem with functions is that it's not really like you don't say just L, right? You say L and then like the argument. That's how you call a function right now. Yeah, I would be able to do this if I did it like Haskell, but I'm not doing it like Haskell. So what? You just want me to have the alias like this? So this means that it is more like a custom syntax thing. Is it very useful? So alias is basically like generating a macro and a syntax with like this is going to be treated like a keyword, I guess, which is just expanded into this like inner AST kind of. I don't know. There's a famous Python bug. If you have a signature like foo a b is empty. Hold on. Python. Wait, do I have Python here? Let's go. Python. I do have Python. All right. Def foo a b is this. Return a, right? Something like this. Foo 1. What's the problem? Wait, what's the problem with Python? Or are you saying the problem with Python is that like, okay, let's say I return b here, right? And then I say foo 1, right? This is going to return me this empty list. And I say foo1 dot append 1 to 3. And then I say foo 1, and it returns me 1 to 3, right? It's like it's returning the same thing. Is that the problem? That has nothing to do with like units though. Great, you solved it. I don't have default arguments yet. I do want to have default and optional arguments and keyword arguments, and like I want to have like this, right? Args and kiwi args, right? Like this. So we can do foo 1, 2, 3, 4, 5. A is 6, right? B is 6. It's always been an issue with languages that have garbage collectors. In C, you need free or C++ plus by value over reference. Yeah, we have like value types. Like Python named args, that's a good feature. I already have the named args. The only difference between like me and Python is that if the argument is unnamed, I cannot name it, right? So like in Python, if you have foo with like a, return a, right? Then you can call the function foo with 1 to 3, or you can call the function foo with a equals 1 to 3, right? That's like the same thing. So in cast instead, we just do like this. We have a function foo, which is you know, like either x into x, and then I call it foo with like 1 to 3, which returns 1 to 3. I cannot say foo where x is 1 to 3. I cannot, right? Instead, we can force the argument to be named, where we have like the named argument. I'm not sure about the priorities. Can I just do this? I guess no. I need parentheses here, right? So I just call foo where x is 1 to 3, and this is like the same thing. This is the same way why Scala was created and branched out from core Java. Which one? Like the value types? Yeah, so like this way we have named arguments. Let me finish what I started, which is renaming the compile AST into include AST. Do I use it anywhere actually? Feediv. Hello, hello. Let me see. Compile AST. Yeah, we have this over here. Okay. So we just say include AST. I think this makes more sense. Because it's same as including file, but we don't include the file. The bot can pin the messages. Oh, Nerdsel was the bot. Oh, wait. No? Wait, what? No, it says pinned by Nerdsel. You pinned it. Include AST. There you go. Test. It was a question. I mean, I don't know. Maybe if is there an API? Let's see. Docs. Is this the one that I'm using? TMI, I think. Pin. There's ping. Pinned chat. I can like get the current pinned message. Right? Private message. Basic Twitch chat message. Yo, I have an MMO. Thank you for the raid. Hi. Hello from the MMO god. Hi, Kent. How are you doing? The MMO god. Right. Were you actually working on the... hold on. You were working on the MMO? How's the progress? Right. Is it, is the next big update coming soon? And I think I never played the actual MMO, right? Or did I? No, I think I did. I have an MMO. How do you play the game? On this website? Why is the website not opening? 4 years. Oh yeah, it's called Retro MMO, of course. Retro MMO. Play. Existing user. Kuviman. What do you mean enter email address? Save. Yeah, I was here before. But I think my brain is too small to play this game. I'm still level 1. The monsters east of the bridge are tough. Alright, so we need to go east and delete the monsters. Which way is east? Is it left or right? Hold on. What's the last update you did? You was writing battle code? Alright, let's go to battle. Is this east? East is the right, right? And west is left? Wait, why is this not working? Is there a settings? Ah, shit, hold on. I guess I can just lower the volume for myself. Requesting the pink house. The lizard uses attack on Kuviman. Kuviman takes 3 damage. Select an action. Wait. There's no title what the action actually is. I mean, yeah, I guess I click and then I see what it is, and then I select the target. Attack on lizard. Lizard takes 3 damage. Alright. What's the health of the lizard? What's the lizard's health? Am I blind? And I don't know what their health is? Is that on purpose? Fireball is strong. I defeated the lizard. There's settings in the top right, but the top right was just the exit button. Or you mean like this subscribe to Retro MMO? Is it that how you get the settings? By subscribing? Oh, settings. I see it. I'm sorry. I'm stupid. I defeated the lizard. Shit, there is another lizard. I'm having 2 HP. I'm going to die. I use escape, but I fail to flee the battle. The lizard uses an attack, and I'm dead. I'm defeated. Is this hardcore? No, I just lose 1 gold. And I restart from the very beginning. Okay, good game. Nice. Valiant effort. Where are some things in the game UI and some outside? I don't know. I don't play a lot of MMOs. I like even like the World of Warcraft is, I think, I don't know. I remember playing it and like being confused by the UI all the time, even though I played it a little bit. I don't know. Like these MMOs, they are the games with a lot of buttons. Always. Right? And I'm having trouble finding things when there's a lot of things. Alright. Anyway, I'm working on my programming language today. I'm not making a game. But there is a game of mine over there if you haven't... Wait, did you play my game, Evan? The Linksider? You played the gem version? Yeah. Oh yeah, that was like 2 years ago, right? When the gem happened. Right. Yeah. Okay. Okay, I didn't have a plan for today, so I'm not sure what I'm doing. But I was just renaming a thing. Compile AST. Maybe I should do something. Evan, what do I mean, feel free to go rest. But what is the most important feature for you in a programming language? I'm making a programming language. We need to know what people need. So I renamed compile AST to include AST, and I think there should be also a compile AST, but a compile AST should not include it. It should just give me the like the compiled thing, so that I can inspect it. I think this is really like good. So you know, when I am having my REPL, right? I have a REPL, and I can see what the code is being parsed into, right? If I just quote let x be 5, then I can see this, right? I say that this is an assign expression where the assignee is an x and the value that I'm assigning is 5, right? So we can see the AST here. And similarly to that, I want to be able to inspect the compiled thing, like for debugging or something, right? Which would be like compile this AST. Right, and it will give me the intermediate representation, which I should be able to inspect. I think this is a good feature for debugging. Let me just do this really quickly, but for that we need the intermediate representation as a value, right, which we don't have right now. So let's just do this. So we have a value which is AST, and similar to that, I want to have this. And this thing can be like multiple things actually, right? Because I can compile into the like I have multiple different types of expressions and multiple things that I can compile into, right? There are multiple things that are compilable. We have place expression, assign expression, expression, and pattern, the 4 things. So should they all be their own types? I guess we can do that. Let's start with just expression. So if I store the expression as a value, and then have a type, which will be like expression is a type. Why not? Type shape expression. 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 Display. Expression, right? Expression. And this is for substituting the bindings. We don't do anything. All right, then for the values, recursive types. Recursive types, expression, value, and value shape has infinite size. So this needs to be boxed, it seems. Just fine. Trade expression hash is not satisfied. Yeah, now I need to like be able to like have the equality here. Maybe I should just have a park. Yeah, I think that would make sense. So yeah, I compare it based on the pointer. Okay, is copy. Is the expression copy? Is my AST's copy? Not? Type shape expression. Let's just say none here. What's this? Display. Value shape expression. So if I want to display the expression, we just write have expression. I do have the display for it, right? Maybe that's all I would do. Maybe I can write some more. The type of expression is expression type. Clone. This is inferable, so if I want to infer the things, I shouldn't be able to infer. Inference for the expressions makes kind of no sense. Infer value shape. Shape expression, return none. Okay. There's one more error over here, because this must be a macro. So is that it? No, that's not like exactly all of it yet. Okay, it does compile, but obviously compile AST does not exist. So compile AST would be just a normal function, right? It's yeah, it's just a normal function, but it's implemented as a native thing. Let's see. Yeah. So we have over here eval AST. So evaluating AST is just compiling it and doing everything. But we want to just compile AST. Compile natives insert function. I guess it's like very, very similar. Eval AST and compile AST. So compile AST can be compiled into different types. Right now, I'm just going to make it work for expressions. But yeah, we just say compile, right? And compile is something that returns a compilable thing. Let's return OK. So yeah, result type is this. I need to figure out what is the result type, right? So I'm going to match result type inferred expect inferred. Right, this is all the types that we can have, but we are supposed to only be compilable into an expression, and if anything else, then I'm going to say fail like some other type, right? I just say that type is not compilable. I mean, it's not compilable, right? It's like what's the name, right? It's something like I'm compiling into an expression, right? It's not like the AST is something that we compile into an expression. And compile into type. Yes, like that. Yeah. So if I have an expression, then I just say cast compile AST. This is going to be like value expression into, right? And over here, and then we store it in a work like so. And cast needs to be mutable, sure. So is that it? And then I need to just make this available in my standard library, right? So eval AST is just a function which is returning t, and compile AST is AST into t. It's like very similar, but over here this is something that is a compiled stuff, right? Let's see. So if I evaluate AST 2 plus 2, then it's giving me 4. But if I compile AST, var not inferred. Oh yeah. So like I do need to specify the type here. So let's compile AST into an expression. An expression is not found. So I need similar to this. I need to say that expression is a type, which is a native expression, like so. Because native expression is not found, so I also need to do that. Interpreter natives AST, I need to copy that and say that expression is a type expression. So now we say expression is just a type, right? Similar to AST. So if I say compile AST, 2 plus 2, compile AST into an expression, right? Then we can see the compiled stuff, right? So basically, when I say 2 plus 2, I'm calling a function. What is the function that I'm calling? I'm calling a generic function, which I'm instantiating with the type, which is not inferred. And then the argument is left-hand side is a number 2, and the right-hand side is a number 2. The reason it's not inferred is because this is an integer. It has the default, but the type itself is not inferred. If I say over here, though, that it is int32, then it will infer that the argument is a type int32, right? What is this? I'm instantiating a template. What's the template? Because 2 is the generic function add, basically, right? And it's generic over the value that we are adding. So it makes sense. I guess it doesn't like... I would like, I guess, when I'm showing the templates, I would like to have the names. Maybe I should work on names, because this is not obvious what it is. But it's declared in the standard library, operator plus. No, it's binary plus over here, right? So this is the template. This is the template. It's for all types. It's a function which is implemented natively, where left-hand side and right-hand side have type T, and we return T. So it would be nice if it just said what's the name. So like right now, everything is anonymous in the language, right? If I say function f is like a function x into x, right? And f is a function, right? It's an unnamed function. It would be nice if we had the names. I want to work on that actually. But this is good for debugging, so I'm going to commit that, compile AST. Okay. Yeah, let's see this. Adding names to things. Right, so once again, everything right now, absolutely everything is anonymous. If I say function print in the standard library, it's just a function, it's just like a function. And here's the type of the function. And over here, for example, this over here, this is the context, which requires that the function needs access to be able to write. And this is an anonymous type, right? So which is called output. So output is a type where write is string into unit, and it is an anonymous record type basically. We don't have named types. If I say option int32, then we know that this is either some int32 or none. It doesn't say that it's an option type, right? Yeah, so like functions are anonymous, types are all anonymous right now, templates are anonymous, everything is anonymous. We need to have names. So I think the way that should work, let me see. Like I don't want to, I think, specify the names. I want just the current code to work. Like it should still be anonymous. Like over here, right? Panic. Panic is a function from string into nothing. And it is a yeah. I mean for natives, I actually have the names. I think, right? If I see what Panic is, yeah, this is a native function. Wait, why is it native function dbg type? This is a wrong name. Hold on. Hold on a second. Why is it called dbg type? Native Panic. Hold on. Interpreter. Natives. Nick. Insert function. Because over here the name is dbg type, so all the native functions right now have this. Okay, that's just it just needs to be changed. I just need to do this. Yeah, so the native functions are the only ones that are named right now. Panic is a native function, Panic. So similar to that, if I declare my own function, which is not a native, like print, I should also say function print, not just function. That's what I want. Fix native function names. So we need to have names to values and names to types. Should it be done for all the values and for all the types though? I don't know. I think for types there is a distinction between like anonymous and named types, right? Because we can have two types with the same structure which have different names. So the name should be given to only like the new types, I think. I start with the values and like functions. Like not all of the values need to be named too, right? Like for example, unit is just a unit always, right? It's just the functions that needs to be named, and templates, and I don't know, maybe macros, right? Which is basically all of these are just functions. Everything else is anonymous. Makes sense, I think. So just a function. We have typed function, which is a function. We have yeah. So yeah. So just functions. Functions need to have names. So right now I'm saying function ID. Wait, shouldn't it say ID? It just says function. Let me see. Function. Okay, I think I just do function. We just try it f function like that, using the display implementation for functions and for templates and for macros too, I guess. This over here is a typed function. This is a macro. So this should, like, I'm still treating macros as different things than the functions, so Yeah, like over here I'm seeing type. So I think it would be fine if I say over here function and over here template. And over here macro. And I should not have called this f. And I cannot call it fn. Okay, sure. Function fun. Macro fun. Fun. Okay, so functions, both typed and untyped, need to be not just debugged, they should be display for function. So if I want to display this, just say I don't include the function here. I just write the name, right? If we have a name. So I guess we should have something like this. We have a name, which I should like I guess it's an optional one, right? We start with anonymous ones and then we assign the names. So basically I match self name. If it is some name, then I write the name. Otherwise I just write the ID. I think that makes sense. All right, and then we have the typed function. Implement the typed function. Command std display typed function. This just does the self f. DBG, I'm not even sure that this is needed. So now I'm missing name, right? So when I am creating a new template, since this is like a lambda, I guess like over here, when I'm making a new function, this is like a lambda. It is an unnamed function. I should say that the name is none, right? And then eventually we assign it to a variable of some name. And this is where we can name it, which means that this is not just an option string, right? Because yeah, like we're cloning it and stuff. It's more like it's like an arc mutex, so that I can change it. Self name lock wrap, something like that. So we start with none, and then eventually I need to assign something to it. And I just do the same for the templates. They are also just functions. You can have names for them. Okay, now the question is, when do we assign, right? And this is where we assign. Let's see. So if I have a let expression, let, we have pattern. So we do pattern match. We do pattern matching, and for every binding, we for the interpreter we insert the symbol, value, and stuff. Yeah. So we are inserting. This is basically assigning a value to like a symbol, right? So should a name even be a string, or should it be a symbol instead? Because we can have two same names but different symbols. Maybe that would actually make sense. Let's store the symbol. Why not? And then, so should it be done over here? This is where we are actually assigning values to symbols. And this is where we are naming them then. Right? And like similarly, we can insert the types. I don't know. Let's try doing this here. Locals insert. Insert place value. I think this is the like final thing. Right? So I should just have value dot name name, like if it needs to be named, name if needed, with the name, right? So a value, yeah, but a value is probably like, it's not necessarily inferred right now, so I should be able to do this only for inferred values, right? Yeah, that makes sense. All right, so we have a function name if needed. Self name is a symbol. Like if I later assign this thing to a different name, it will keep the original name, is the idea, right? Okay, and then since this is a value impl, it is either inferable or not inferable. So I think for inferables we don't name them at all, right? So match self impl. If it is inferable, then I don't do anything. But if it's a non-inferable value, then I say value name if needed. And so I'm forwarding this to the value shape. And value shape name if needed, name symbol. So over here we just match over self, and like some stuff needs to be named and some stuff does not need to be named. Let's make sure that nothing is being named by default using nothing. Like that, like that. But macros, native functions, functions templates, these 4 things, they need to be named. They have different types though. This is these 2 have typed functions. Native functions are already named, so it doesn't really matter. Yes, native functions don't matter, but yeah, functions and macros are typed and templates are not typed. So we have here f, and then we say f name, lock unwrap. Let's just say f name if needed name. And over here we also say f name if needed name. So now I'm forwarding this to the function, and typed function is just deriving to function. Yeah, makes sense. So we implement for function name if needed. Name is a symbol, so we say we are matching self name lock unwrap. If it is let's see, current, I don't know, self name is that right? So if self name is none, then self name is some name, just like this, right? I think that's all that is needed, and maybe I already have names then for my functions. You know, to move out of impl. Yeah, this should be of course. How long does it take to actually compile my stuff? How many seconds has it been? It's been like 30 seconds already. This is debug builds. 30 seconds exactly. Okay. Well, it is compile and we're running. So let's see. If I have a function print, now this is a function print, right? Wait, I know that it's a name. So basically, if I have a function, so like, look at this here, right? If I have an anonymous closure, which just takes nothing, returns nothing, then this is an anonymous closure. I just show its ID now, right? But if I say let f be this anonymous closure, then f is now named. And if I say g is equal to f, then g is still the function f, because we keep the original name. Does that make sense? So like, we don't have a dedicated syntax for like creating named functions like in Rust, right? Like function f, which is returning nothing, right? We instead just say let f be a closure, and it just assigns the name automatically. That makes sense, right? So this also means that, let's say that I have a function, you know, like create a function. So it's a function that is returning a new function, right? So it's a function, let's say it takes like x, int 32, and then it returns a function which returns x. Let's say this, right? So if I say create function 1, 2, 3, then we make a function that every time we call it, right? Every time we call this function, it returns 1, 2, 3. So this is creating an anonymous thing. So I can create the anonymous thing and then bind it to a value, right? returns 1 to 3. This create function 1 to 3, and now returns 1 to 3 is actually a named thing, right? So that wouldn't even be possible if I had like a specific syntax for naming things as at the same time as I'm, yeah, because like over here we don't even know what name I want it to be, right? That makes sense, I think. The language is sick. Yeah. I think that's cool. So yeah, now if I try to basically compile AST, like, you know, 2 plus 2, then we should, if I compile this into expression, right? Then we know that this, okay, so this is still a template which is unknown, right? This is still an ID. Why is this an ID? Let's check that. So this is supposed to be a template named like binary operator plus. Oh, it's because I never assign it to a name. I know why. So over here we have standard library, right? So we have binary plus. Binary plus is just a syntax which is implemented by this, and this is anonymous, right? I never actually assign it to a name. This is not a let. This is me implementing the syntax. Right? So in order to assign this, right? Like because I cannot even like name a function which is the function add, right? I can only add things using syntax. But it would be nice if I had a way to like refer to the addition as like a standalone function, right? So we say let operator binary plus to be equal to this, and then we assign this to operator binary plus. So now, since I am assigning it like this, it means that once again, if I compile AST 2 plus 2, then we will see that it is an operator binary plus instantiated with the not inferred type. Yeah. That makes sense. Right? If I specify the type, then we will see the type is int32. Okay. And also this means that now I can see like an operator binary plus is this thing, which I can call with like, it's basically just a standalone function where left hand side is 1 2 3 and right hand side is 4 5 6, and this is actually adding things together, right? So I can use it as a normal function instead of saying 1 2 3 plus 4 5 6. This is basically what it desugars into this function call, right? And this is not just a function, this is a generic function. So the full syntax is this instantiated with int32. Yeah. Yeah, I think this is nice. So I kind of want this all things to be named. So let's just do that. Let's do all of these operator binaries. Const is that operator binary that. Like so. Lemon Spice Krypton looks so much better on my screen than yours. You're stuck with Neon because you like character. Why does it look better? Maybe you use a smaller. I think it depends on the font size, kind of. Maybe. Low spike. Yeah, I guess I want this for all like implementations of syntax, like a unary one is also Needs to be done in a similar way. Let's do this is equal to that. And then I say const this is equal to that. Operator plus equal. So operator plus equal though, like this one. Wait, why is the unary plus? Wait a second. Hold on. What's happening? Oh, yeah. Over here, I'm implementing the syntax with a function, not with a macro. And over here, it is with a macro. So it's already there. The functions are already there. I should not have done that. But like, why am I even going through the thing? Right? I can just do that. And that. Yes, this is the same thing. I guess like the problem is this is named here and this is unnamed. But it just means that in the syntax, unary operator. This is unnamed. So yeah, I think I just need to simplify this thing. This is unary plus, unary minus, like so. Binary, and then these things, and these things are, they were macros, which were just calling the function, and it is just not necessary anymore, right? We already have that. Down. I think I just remove this and say that. Operator plus equal, I cannot have this as a standalone function. I cannot have places as values right now, at least. So this will be just a macro. stdlib import failed, unexpected token impl in standard library over here. And a semicolon, I forgot semicolons. Operator unary plus not found while compiling this. No, we just called unary plus. Is that op unary plus? Okay, so negative 1 to 3. Unary minus doesn't work for. Oh, okay. So this is now okay. All right, I see. So this should be a tuple. That's why I did it, I guess. Okay. So we have a difference between a value and a tuple with one element. And we are going, and we're back to this question about like the tuples. So there's two special tuples. The tuple with one element and the tuple with 0 elements. The tuple with 0 elements is some like can or cannot be the same as a unit type. And the tuple with one element is different than just surrounding the thing in parentheses, right? We need like that, the trailing comma, to make sure that it is a tuple for this to work. Two-step, hello. Been watching some of the recent language VODs, been learning some type theory, nerdy stuff. Thanks. I've been learning some stuff too. Hold on, let me think about this. If I have a function f, right? Which has the argument x. It's a function that returns like it's a function that takes an int32, right? It is not taking a tuple. Yeah, like what I'm trying to say, should I treat the tuple with one element same as just this element? Probably not, right? That's different. I'm just imagining if you are doing some code generation. If you're doing some code generation, you're generating a function that takes like a certain list of arguments. If this list has the length 1, but like if you're like making a generic macro that is generating a function, right? Then and then it so happens that you have generated a function that takes a single thing, then this is a different than just having like the value of int32 as an argument right now. In Rust, yeah. Oh wait, hold on. I already have the syntax with trailing comma. I guess I do. So right, yeah. See the difference here. This is taking int32, and this over here is taking a tuple with a single int32 inside. Right? And that's the difference. Devin's dev, hello. Like so in Rust you can have trailing commas in the function arguments and it like doesn't matter, but function arguments are like special. They are not treated as types. Like this also means that when I'm calling the function, I cannot just call this function with the argument 1 to 3, right? Because I need a tuple, right? So I need to call the function with 1 to 3 like this. You don't know what you're looking at? You're looking at the REPL of my language. Of cast. Have you seen cast before? You have been on this stream before, right? Here's the thing though, when I'm declaring the syntax, for the unary operator plus, this over here has a single unnamed like inner expression, right? But when I'm converting this syntax into like a macro invocation, the macro takes the argument which is like a tuple of all the inner expressions, right? For example, the operator binary plus, we have a tuple with a named left-hand side and named right-hand side arguments. And in this case, if it's 1, it's actually a tuple with 1 element. So something like this, right? Is what we want. All that code made me confused. I'm not familiar with functional syntax. It's not like very functional, this syntax here. Is it? I mean, this looks like that in TypeScript, right? I guess aside from the like type annotations. But this is how you create a function in TypeScript and JavaScript. For all, I think I might want to change the syntax actually for this. I don't like typing for all. What if for generics? So you know how, like, in order to create a function, we just say arguments, you know, arguments into body, right? That's how we make a function, right? This is a function definition where argument is like arguments, and this, yeah, it's just a function definition where argument is this and body is that, right? And then if I say for all arguments body, I think this is a little bit too much syntax. For, like, this is the same as a function definition, but instead of a function, it's making a template. I think we need this to be a little easier to type. So what if we just do this? Arguments body. This would make it like ambiguous if I want to start with the square brackets though. We can also have like this arrow here. That is still weird. Like imagine, like, how do you make the generic function in Rust, right? You have a function, you know, over here you have like generic arguments t, right? And then you have a normal argument x of type t, which returns something, right? And over here you have the body, right? That's the syntax definition in Rust. So in cast, if you want to do this, you have a for all t, and then inside of these curly brackets, you make the function x of argument t returning something, and then the body is here. So I just don't like these curly brackets, first of all, so I want to get rid of this. If I do at least like the for all, I think this can work. And then we might just remove the this completely. Or maybe, what if I just do for? You know, Rust has the syntax for. Rust has the ability to write something like for a for a function a i32. It only works for lifetimes though, but Rust has this syntax. If I try to do this in Rust, but not with a lifetime, what is it going to say? If I have type f is a for t function t into t. Does this work? Only lifetime parameters can be used in this context. Yeah, this only works for lifetimes. But there is an issue. Does this mean that they want track an issue for non-lifetime binders? So like they actually want this to work, right? But RFC needs to be written. There is no RFC yet proposing this thing. Support non-lifetime binders feature. I'm curious if that could work with const generics. Then they call Zig weird. Wait, are they calling Zig weird? Who's calling Zig weird? What, like in terms of syntax? I don't think I have problems with Zig syntax much. This over here, 4b block cipher backend fn1b. Yeah. Okay, yeah, because you want this in trade bounds, right? So you want to encrypt with backend where you have an argument, a function, that this is a function that is generic. So you want, wait, how do you even do this? You can do like a generic function that works for all constants. Do they actually want to support that? Does that mean that you need to have like a generic as a value, which you don't have in Rust? The reason it works for lifetimes, because lifetimes they are completely erased at runtime, right? And it still corresponds to the same function. But if you have a function that is generic over a constant or some other trait, then like every single instantiation of the thing is going to be compiled to a different function. So you cannot treat it as a value in Rust, no? My friends think the Zig syntax is weird looking, but then there is Rust. Syntax doesn't matter too much. I don't know. All the languages look fine to me. There's a reasons. What exactly do they think is weird in Zig? Do I think something here is weird? I don't know. I think Zig actually makes a lot of sense in terms of syntax. I don't think there's anything weird. I don't remember anything weird. Right now, it's possible to emulate this manually by implementing Clojure. But it's incredibly annoying and verbose. See the block Clojure trait. Block Clojure. Wait for block backend users. Wait, how is this possible? Encrypt with backend? Where F is for all block cipher backends. F and ones. Zig has Rust.js var names as struct fields. You don't have to repeat names when they are the same. Rust.js var names as struct fields. Let me remind myself how it works. Struct. Isn't this literally the same as in Rust? Specifying the field. This is literally the same as in Rust. Or do you mean like this, when you are instantiating, like when you're constructing the thing? Oh, return foo instead of dot foo is foo. They don't have the shorthand syntax for it? Oh, I see. I see what you mean. Yeah, over here, right? X is equal X. This is what you want. Do they not have it? So my syntax is actually very similar to Zig in that sense. It's because I have, if I have X equal 1, 2, 3, right? So X is this. If I want to have X equals X, like this. So this is like a struct where the field X is equal to 1, 2, 3, right? But if I want to, I do have the shorthand syntax for it. Just say dot X, and then and it's the same thing. Dot X and Y is X. So this has like two fields, X 1, 2, 3 and Y 1, 2, 3. Over here we use the shorthand. Do they not have this in Zig? Why not? I mean, I guess like maybe because like this is more explicit and they value explicitity. Is that like a design choice to not have the shorthand syntax? Or is it just not implemented? Zig issues. Shorthand field syntax. Has it not, maybe it has not been proposed or something? Get rid of the dot and tuples and enable structured literal syntax. Yeah, I don't think this is going to happen. Or you mean like this trailing dot? Trailing dot, I feel like it maybe is not necessary. Anonymous struct literals. Do they have this where field? Yeah, like they have always the, it's be different. What about the short and I would say that examples 2 and 5. 2 and 5. This is different. It's different. I think it just, maybe it was never proposed by anyone. That also makes more readable. What makes more readable? Like the way that you don't have the shorthand syntax? Because like over here, I just say .x. If I don't say .x is equal to x, like, I mean, this is more readable than this. That gender example is hilarious bait. Not having to repeat them is better when you already have... Those dots are annoying. I don't think they are. So the reason I have the dots, though, I already talked about this before, is because we have a mix. So like you know, there is a difference between you know, we can have tuples, right? X and Y, right? Let's say that I have X is 1 and Y is 2, right? So I have X and Y. This is a tuple with 2 unnamed fields, right? Let's say that I have the syntax X is X, Y is Y, right? Then it's not like if we require an explicit equal always, right? Or like a colon or something, then it's totally fine, right? But since I do want to have the shorthand syntax, how do I differentiate between X, which is unnamed, and X and Y, which are named? So the way this is different from that in Rust is in the parentheses. So in Rust, for like named fields, you do curly brackets X, Y, and for unnamed tuple, you say normal brackets X, Y. But I don't think I like that. And also, we have mixed things in cast. So I can have a couple named arguments, and I can have a couple unnamed arguments, like this, which is a combination of a tuple and a struct with named fields, basically. So I have 2 unnamed fields here and 2 named fields, which is useful, right? It's a struple, yeah. It's a struple, yeah. I mean, I still call them tuples, but maybe I should just call them structs. It's just structs should have unnamed fields. I don't know. I'm just calling all of this tuple right now. Why? So the reason why is because we want to have like, I'm using tuples as arguments for functions. So right now, all the functions are having a single argument. If you want to have a function with multiple arguments, then you just use a tuple. So the tuple, and then I want to have named function arguments, and I want to have unnamed function arguments all at the same time. So I just do this. And like for some functions, you want some arguments to be unnamed, some functions you want to be named. Some of these named arguments you want to be optional, right? So basically, you like let's say that we have a function sort. So we just sort array with like key function be something like similar to Python, right? So we would just say that key function is like something like this, you know, element into, I don't know, element plus 2 or something, right? We would just do this. You asked ChatGPT for a description of my language. I said some pretty nice things about it. Wait, ChatGPT knows about cast? Do you know about cast language? Oh, it's searching the web. Yeah. It can search the web, right? Yes, I'm familiar. All right. Cast supports advanced features such as delimited continuations. By the way, I should like actually do this as soon as possible. We had delimited continuations in the OCaml version, but not in Rust. I should do this. Yep. There can be confusion between structs and tuple if you allow the variable named fields. Yeah, I don't know. Like I think like this is just a little bit, I guess, unfamiliar for a lot of people. But like I'm not even the only like we are not the only language that allows for this, right? Like Zig is doing the same thing. If you want like this also, it's kind of nice because if you see that it's a dot followed by a name, then you know that it's a field, right? You don't need to look at the parentheses somewhere outside. You just look over here and you know that it's a field named key, which is equal to this value. I don't know. I kind of like the dots. Yeah, I like them. What I don't like about the Zig is this like trailing dot, right? I don't have the trailing dot. I'm not sure why they have the trailing dot though. You prefer key colon element? The reason I don't do colon, I was doing the colons originally. You won't have types for this. Basically, let me show you some other examples, right? So we want to have a thing where x is a field which is equal to 1 to 3, right? And then we also want to type it. So we do x is of type int32, which is 1 to 3. We can do this. If I cannot do this, if I have colons, right? Like it should look different than a colon. Yeah. Also, I'm still using a double colon here instead of a singular colon, like most languages, I guess. Or at least like most mainstream languages. This is used in a lot of functional languages, right? The only syntax in cast that I don't like right now is the I think the variant type syntax. So we have optional types, right? For example, it's an enum. So it is either a sum int32 or none, right? So you see this like colon here. I'm using colons for specifying the variants. So if I say variant sum 1 to 3, then this is the variant sum of some type, right? If I say that this is an optional int32, right? For example, it would be that. But I don't like this colon here. But I don't know what else to use. So a lot of functional programming languages, like why do I need this colon, right? Like Rust does not have this colon, for example, but Rust makes it ambiguous because of that. I'm gonna show you an example in Rust why this is actually bad, and I don't want the Rust syntax. Let's have have function main, right? We have some option, which is sum 1 to 3, right? So then I match the option, and I say like sum 1 2 3 some x, then we, I don't know, debug x, I don't know, print x, right? And if none, then we don't do anything. So you see how over here this is going to actually compile, but I have a typo. But I did not mean to bind this to a variable named none, right? I mean, obviously we have a warning that this variable has a different name, right? But this is bad. Like this, like do I mean a variant named none, or do I mean a new variable named none? It's not obvious from the syntax, right? Which is why I want there to be more distinction between specifying a variant and specifying a variable. So I'm using a colon here, basically. In functional programming languages, it is basically based on capitalization. Yeah, that's the reason for casing rules in the first place. You don't agree? Um, sometimes you do code generation, and if you do code generation, you cannot always do the proper casing. And also, this is not in first anyway. Weren't you talking about the definition of the type? This is how a pattern issue? Or do you need to call in the type definition? In the type definition, just I want the syntax to be consistent when I'm defining a type and when I'm using a type in like pattern matching, right? Like, why should the syntax be different? The syntax should be the same for all the variants in all the places. Just same as like defining a tuple type and using a tuple value should have the same syntax, right? Which is actually not the case in some languages, like OCaml or something, right? They like, if you want to define a tuple, then you have like int32 times int32 because it's a product type, but in order to construct a tuple, you just say 1 and 2. They have a different syntax for those, but I think it's really weird, even though it makes sense, like for mathematicians maybe. From Scala, it's just not the same most of the time. Wait, how does Scala do it? Scala... Scala. I was actually looking at Scala yesterday, and specifically for Scala tuples. So Scala has a dedicated syntax for a tuple 1. Right? So in Rust, we just have the... in Rust, we just have a trailing comma, and that's how we make a tuple with one element. But in Scala, you say tuple 1 with a variable inside. That doesn't have any examples. Yeah, in Scala, you just say tuple 1 x instead of saying just x, comma. Weird. Anyway. What was I looking at? The Scala ADT, I guess. Let's see. Algebraic data types. We have an enumeration. You will have G ADTs too. Nice. Okay. Maybe. I'm still not sure what this is useful for. Much. Yeah, you say case this. No. Oh, case nil. All right. Is there a Scala playground? Scala online compiler, interactive playground, Scasti, this one. Do you have option? B match. B match instead of match B. Okay, sure. Illegal type, use unit instead. Oh yeah. Yeah, they just call it unit instead, right? Yeah, this is, yeah. The type of a unit is unit, but the value of a unit is like an empty tuple. Weird. So what if I just over here say none? What is going to happen? So they say not found none. Did you mean none? Okay, but if I say none with underscore, then it's going to compile. So the difference in Scala is just the casing, right? So similar to Haskell and OCaml. I don't like making this dependent on casing though. I don't like it. That conflicts with a field potentially named _1, considering numerals are not valid identifiers. This preclude otherwise permissible naming. Now you also don't like it. Yeah, so like in Rust, this is not enforced. This is a warning. In Scala, this is just like this. Like what is this? Like it's a lexer that's like can you even have a variable? Can you even have a variable with a uppercase name, right? Up is 0. Can you do this? Is that not how you do it? You say val, right? Wait, hold on a second. So you can have a value. Wait a second. So what's the rules for this then? I would expect this to be a problem. I say case up. The value of types int and option cannot be compared. Wait a second. Hold on a second. Is this sum 1, 2, 3? This is non-exhaustive now. Wait a second. Wait a second. Hold on. So you can, in casing, this is basically comparing B with this like constant, right? Dependency on casing is a bad thing because you said code gen, but I think you can expect that if someone doesn't follow the rules, they can expect problems. So you say that dependency on casing is a bad thing, but then you literally said that you don't agree earlier, that the reason for casing rules are there in the first place. I need a solution for this, but I don't know what the solution is. I think the solution of requiring this is actually of requiring some symbol before is better than depending on casing. Maybe it's just the choice of a symbol of a colon is not good. Maybe I just need a different symbol here. What are all the different symbols? What about a quote? Quote is a fast thing to type. I only use quotes for like quoting the ASTs, but then I need the brackets. So if there is brackets after quote, then this is the AST, right? This is AST. But if there is no brackets and just an identifier, then this should be, yeah, like this is not even parsed right now. I'm expecting the opening bracket. Some string at option. going to end up using dollar. Dollar is used right now for interpolation inside the quotes. Right, like this. If I say x is 2 plus 2, and I say this like 2 plus x, this is going to result in me like placing x as the right hand side of this expression. Yeah, which makes sense. Wait, by the way, is dollar a good symbol for interpolation? Gray March is cooking. Hold on, I think we need to go deeper. Greek first letter. No, I don't want to go Greek. No, we need like the normal keyboard without any Unicode symbols and emojis. I don't like emojis. No. No. Last character capitalized is whether it's async. My position is that depending on the casing is fine, but requiring it is a problem. Yeah. But what about this? By the way, remember Nerdsel we did last time? The thing where like we can say sum 1 2 3, right? Right now sum. I will show you more problems with the syntax. We try to not have too many parentheses. So like I can call a print function without parentheses, right? We can do this with parentheses, but this is just enforcing the like the priorities, which doesn't is not needed for functions, right? So because of that, I want to be able to print, or I want to be able to debug, you know, debug sum 1 2 3, right? What is this? How should this be parsed? You know, and like here's the problem. Like if we don't do the symbol, then like how do I know that this is a variant and this is a function? You know, like like it's all weird, and like we will end up needing parentheses everywhere, like Rust does, you know. So because of that, if I do a colon, this was supposed to work, but we actually broke it on like I think the last stream, because I commented this syntax. Let me show you here. This over here. If I do this, then this is going to work. dbg is sum 1 2 3. No, I think the priorities needs to be changed, but I like this is kind of needs to work. No, wait, hold on. Type is not inferred, failed to hash. Oh wait, it's just not inferred. Okay, dbg. I guess with a hello, with hi, it will work. No, it doesn't. Oh yeah, because like this doesn't mean that it's an option. Yeah. That makes sense. I think colon is fine. It's just like a little weird. Like we have colon and we have double colon. They look similar, but they mean like absolutely different things. Kind of. I don't know. It's fine, but yeah. Yeah, I guess if we have a function, yeah, like in this case, it cannot infer it, right? But let's say that we have a function. We have a function f, right? Which is a function from option, which is option, I don't know, int 32. And then it just returns, like it just debugs, oh, let's do this. Right, so f, sum 1 2 3. Now this works, right? There you go. So if I don't require this colon here, then I wouldn't know like if this is a function called with sum and then we are calling that, you know the difference here is weird, right? And then we so like if we do sum 1 2 3 and I want to specify the type so that this is inferred, right? So in Rust you can just say option sum, something like this. So we enabled this last time, but the problem is, once again, how is this option sum 1 2 3 different from me calling function f with argument which is sum 1 2 3, right? in this case, I'm specifying the type of this variant. And in this case, I'm calling a function with this variant. So like I need this syntax and this syntax to be different. Which is why I was deleting that syntax earlier, I guess. So if I want this to be like type ascribed, then right now I would need like sum123, which is like option in32. Option, no, underscore, right? But this looks weird, right? I want something more similar when I specify that it's an option dot sum. I cannot really do a dot though. Or can I? Option dot sum. If I do a dot, this means that types need to have like basically like fields which are their constructors. But what's the type of this? Right? So the so like in Rust, if you have a option sum, this is like a function that is returning the option, right? But then option none is not a function. It's a value already. Like, you know, it's a little weird. You like colon option underscore and option dot sum equally? Well, option dot sum doesn't work right now. But like, so like if I uncomment this, then I have like the reason I don't like option dot sum, because so like dot is used for fields, right? So if I say dot sum x, then like if I use dot, then I want to use dot to like construct the variant itself, right? I would like this syntax, dot sum, instead of colon sum, and this would make sense to me, right? Instead of colon sum 1 to 3, I want to say dot sum 1 to 3. Sum dot x, that doesn't work. Yeah. So like I kind of like the dot here, but the dot syntax, it is conflicting with like the field syntax, right? So how is dot none? Well, I guess the only problem is if I use the variant with no like associated value. So like dot sum 1 to 3, I can parse this kind of easily, right? Because if you are specifying a field, then you either have like an equal here, or you just end immediately, right? So if we're using to like have a field and then I call it, then we can infer that it's a variant. But how do I differentiate the none? And enum doesn't have fields. Why is it a problem? Because I don't know if something is an enum when I'm parsing code, right? So it would be harder to like. That's why it makes it like harder to read the code, because it starts not only depending on the syntax, like in Rust, but also on like what are the variables that we have in scope or something. Right? Like over here. Like if none is in scope, like let's say that I have my own custom enum. You know, I have module M, and inside the module M I have enum foo, and I have A and I have B, right? So if I match M foo A, if I say A and if I say B, this is going to Oh, they actually have an error this here. The pattern binding is named the same as the variant of the type. But if it was a different name, if I just use C and D here, this would be just a warning and not an error, which is weird. So it says just a deny by default warning there. Got lost in the convo. Yeah, we just going all over the place. Yeah. But I guess we're discussing the syntax for variants. What should be the syntax for constructing variants? And it should be the same as like pattern matching and describing the type itself. And it should not conflict with existing syntax. So in Rust there is a conflict. Because over here, you cannot really tell by just looking at this code if this is pattern matching and like assigning, if this just matches everything and assigns it to the variable named C, or if this pattern matching a variant named C which takes no arguments. Like these two things have the same syntax. Which I don't like. But then there is like a lot of other problems with even my current syntax. Option.none. Yeah, so like the biggest problem is with the variants which have no associated data, like none. I'm aware whenever a programming language gives stenography vibes by trying to encode stuff in things other than words and braces, it's a bit of a smell. Kind of like people returning -1 sentinel values from functions. Trying to encode stuff in things other than words and braces. It's a bit of a smell. Wait, what are you referring to? What is things that is not what? Sure, encoding is the right word. Since it's like Golang's treatment, it's mostly for the human, but since we are enforcing a convention, I see no reason that the language cannot use the same hints for disambiguation. Like when people say foo is a type and foo is not, it's kind of dumb. Everyone does it, but it's dumb. Yeah. Well, I mean, in my language, I am using the types with lowercase actually. I mean, even Rust is like some of the types, like the native ones, are starting with a lower case. Why actually? Why am I making option with a capital? It's weird. And either and result. Should I not have them like that? It's weird that this is lowercase. Some things are lowercase and some things are uppercase. I do agree with that. That's a crazy opinion. Disambiguating types from data is important, and adding special characters to disambiguate is needlessly verbose. Having a thing type and a thing variable. Yeah. True. I should not be thinking about syntax. I was going to add names to things. I should add. I should have named types instead. So I added named functions, and I should have the named types. Thinking about syntax just takes forever, and we never agree on anything. Let me just think. Like I had this. Like if I say dot sum, this would be the best. But yeah, the problem is like how do I differentiate between dot none and dot none being a field? You know, like what? How is it different? Right? If I have a like dot x, this is the syntax, which is shorthand for dot x equals x. You know, so if I see dot none, it's shorthand for dot none equal none, right? That's like what it looks like to me right now, which is why I did not use the dot, but instead a colon. All right. Anyway, yeah, we should stop syntax. Yeah, I didn't even commit the names. Do you see this, Raymarch? So I have everything anonymous in the language, kind of, but I implemented naming now, and the way it works is that if you have a closure like this is unnamed closure with just ID 4322, but if I assign this to a name, then this starts to be named function, and if I assign it to a different name, then the name stays the same. So G is still the function f, because that's how we originally named it. Does it make sense? So yeah, now I want to do the same about the types. I guess it's kind of similar, like it's literally similar to Zig. How does Zig do this? Maybe Zig is doing the same thing. Like you know how your like generic structs are actually returning anonymous structs, right? Is that literally how Zig is doing it too? I want some example. Zig generic type. Like in no, not int array. Yeah, over here, list, right? So you see how list is basically a function that is returning this anonymous struct, right? So this type over here is actually anonymous that we return from this function. But then it is assigned to the name list here. Right? It's based on like the name of the function that is returning this anonymous type. Right? We literally have the same thing. We have functions returning types. I just think this process of people having to think about how to morph their identifiers all the time is kind of strange. Doesn't feel clean. Putting m underscore in front of stuff, etc. I agree that transforming meaning into identifiers is a chore. So what's the solution? Do we allow white space in identifiers too? It's weird that for some very arbitrary picked things, we decided that the identifiers have to do the disambiguation. Yeah, I don't like basing on a case. It's definitely one of the solutions, though. We can enforce it, but if I enforce it, like I don't want it to be then I don't want it to be a warning. Then I want to enforce it if we do it. Like I want to then enforce that all the types or like all the variants, like I don't have the problem with types right now. I have problems with variants. So like variants, which is like basically type constructors, right? Those should be called with like capital letters, and the variables, they would be a lowercase. But it is weird, right? So the reason it is weird, especially in my language, because types are values, right? Types are values, which is different from like a lot of languages, right? We can assign, like, this is int. We can assign a type to a variable. Similar to over here, we have comp time t type, right? So this is a variable of type. They do use uppercase here, but like, does it mean that like this should be uppercase based on the typing? So variables have different naming convention based on their types, you know? That's also weird, right? So sometimes variables, they have uppercase names and sometimes they have lowercase names based on their type, which is very far, right? I wanted to be disambiguated earlier, if we need it, you know. And I mean, yeah, we don't need the disambiguation between types and values because types are values. The only problem is variance. Okay, so how does Zig do this? Can I have Zig playground? So we have list, right? Function main. Can I like debug the type or something? Why cannot press enter? Why cannot press enter over here? What is this playground? Why can I not press enter? To have a new line here. What? Why is this line number here? The convention is type names or Pascal case. Yeah. Let's instead go to projects, I guess over here. Source, Zig. Over here, test Zig, right? Let's go here. Function main. Void. Zig run test Zig. Okay, there you go. So if I have this list, whatever, if I have this list, use of undefined allocator, std.allocator, std.allocator, right? So we do this, and I have so list, is it I32 in this language? Value of type is ignored, right? So yeah, is it let list is that? No. What do I do here? Const and use local constant underscore is list, right? So we do this. Can I show the type? Can I inspect it? Can I debug print it? It's var const. How do I print it? Like, can I debug what the type is? Or can I guess what I can do is something like try to assign like variable x, which is type list, is equal to 1 to 3, right? Because this is going to say that I have local variable is never mutated. Okay, const. I can do this, right? But this is not supposed to compile because the type is different. So it says a root struct in file std. Okay. Why does the language server not tell me this? stdmem. So yeah, see over here, we expected type test list, right? So it does know that this function, so this function returned an anonymous type. This type over here is anonymous. But it still shows me in the error message that this is test.list with I32, right? What if I have something like function list2 comp time t type, and it just returns a list t. So if I say list2, is this going to be called the list2 or list? It is still called list, right? So what is it based on? Maybe it's based on whether when I'm calling a function, I remember the name of the function and the arguments. And when I'm returning from a function, an anonymous struct, I'm assigning the name to basically the function that I called. Is that so? This is the shit that used to keep me up at night, and I realized I really approve of the way Rust did it. There are problems with Rust, but I don't consider this to be one of them. Let's say you do snake case types and variables. Soon enough, you will see widget type and widget var in the wild. Yeah. Yeah, sure. Maybe we should rename all the types to capital letters, but it still should not be enforced, I think. Like look at this code over here. Should I call this, should I have this variable? Like I'm literally just calling the variable capital letter because it's a type, but it still is a variable. Right? But they do call the type itself with lowercase letters in Zig even, right? So yeah, it is not consistent in Zig, it is not consistent in Rust. If I make my own language, should I call this type with an with the like upper score, because this will allow me to have you know, let type be equal to int32, you know, we actually, this makes sense to me, right? We want to have a variable named type which has the type, right? We do want this. Do we rename all of the like native types too to be uppercase? Do we? This is what Kotlin does, for example. Not sure about a lot of other languages. What about Swift? I don't know why I chose Swift to look at, but Swift has string uppercase. What about integers? Get started. Read a tour. Yeah, they do have types with like uppercase too, right? Over here. Should we do this? Maybe we should. Maybe we should. All right. Anyway, so I think we want to do the same as Zig does, right? So so there are two things. We have generic types and we have non-generic types. When I say non-generic type, right, something like this, const list int32 is a struct with like items, this, right? Let's do that. Of int32. That's how you do it. Undeclared i32. Right? So this is a concrete list. If I say that this is a list int32, then this is going to be named test.list int32. So this is different right? In this case, we assign the anonymous type to a variable. And this is where the name gets assigned. And in this case, the name is being assigned when I'm calling a function. I'm not assigning to a variable. Right? And I think we want to have the same thing. Personally, you like lowercase more for types. I mean, yeah, like the problem with lowercase types is that you want to be able to have like function foo, or I mean variable foo of type foo, right? And this is possible to do with both of them having lowercase in case they live in different namespaces, right? But if they look and in the different, like imagine if we had like a type of type, right, which is like int32, and then next I have a type of type, which is like int64. So in this over here, this type is now not an actual type, it's an int32 now. So it has different meaning, kind of, right? But if it was an uppercase, that would work. Okay, we can keep talking about like the the casing and stuff, but I do want to add names to my types, similar to Zig, I'm assuming. Is there like any documentation of that? How does Zig name types if they are anonymous? Like, is it like documented? Because like everything is anonymous, right? Like, okay, hold on. Let me try this again. What if this function, before returning in this struct, it will say const result be this, right? And then I return result. Is this going to make this anonymous struct be named result? It's not, right? So what are the actual rules? List 32. Wait, hold on, it is! Look at this, it says test list result. Why is it not test list i32 result, though? Let's have something simpler. Let's just have over here, you know, like value is of type t, right? Is y const. Wait, how do you initialize a struct in Zig? Const y is, you do this, dot value is 1, 2, 3. Right, this works. This works. I want this to be a list i64. Look at this. It expected type test list result, but we found test list result. Yeah, that's why I asked. This is a bad error message, right? It should name this type test list i32 result, but we found test list i64 result. It literally, like, the error message says that they are the same, but they are different. So if I am making this in my language, I should include the arguments to this function here, right? Why are they not doing it? I don't know. That variables widget types widget there, Raymarch will be happy now. Yeah, I mean, we can do this. Yeah, we can do this. I already have namespaces, right? I mean the type in let's see over here, the REPL, right? REPL. We can say type std type is int32, and I can have type std type is int64, right? Because that type is a variable that lives in this namespace. It's just imported by default, but I can just do this. Right, and like it still is usable even though I have overridden this. But if I try to do type is something, then this will say like I expected an int64 but I got type, so this doesn't compile anymore because I have overridden what the type actually means. Okay. All right, so the rules for naming the types should be that first of all, when I assign it to a variable, the variable name becomes the name of the thing, right? Yeah. Oh, wait, hold on a second. We can before doing this with types, like, you know how they show here test.list.result, right? So they have the full path, which I don't have right now. I see his boys. Hello, thanks for the raid. How was your stream? And what were you doing? I'm right now working on my language, and I'm trying to make my types named because all I have is anonymous types right now. So I was looking at Zig because Zig is working kind of the same way. We have anonymous types, which are then being assigned to variables, which is when they actually get the name. So I have this problem even with functions. By the way, I should call things, right? Function names. Let me finally commit this. So if I have, let me see. If I have like a scope, and inside the scope, I have a function. Yeah, also like, shouldn't I name things when I'm assigning them to fields? You know, like if a function f is a field in a struct like this, shouldn't scope.f be a function which is named scope.f? What if we do this in Zig? What if I do it in Zig? So what if all of this is working inside like you know, like a module or something, is a struct with these things? That's how you do it, right? And then over here I say module.list. And over here I say module.list. It will say test.module.list, right? Yeah, it will. It was desperate with proc macro derive, trying to understand and how derive features work. Nice. Derive macros are very useful. Get rid of boilerplate. You need to some your minimal channels again, so you make your messages sound less serious again. Derive is easy. Yeah. So wait. So how does this work exactly? Wait. How does this work actually? Like, it means that when I'm let me try this. I want this code to be done over here. And then I want to take a look at the error message, right? Because this is already in scope. So should this be called just list in this scope, or should it still be called module.list? Is the question. Use var or constant to declare a variable. Wait, why can I not do this? It's different. So this is at line 24. At this line, but this line works. Wait, what? Oh, because it's because of the lazy evaluation, right? If I never use X, then it's not even trying to compile this, right? So if I say module.x underscore is module.x, is that what I do? And then we have the error in line 17 over here, which says expected type test module list result, right? So it's still showing me the full type, not the type based on the current scope. Okay. Is dot a shorthand for a map? This is Zig. This is a shorthand for constructing a type, constructing a struct. So if we're writing Rust, instead of this dot, we would have like this struct name. You know, you have struct name, and then you have struct fields. But Zig, it can infer the struct name, so you just need a dot. And you need this dot, I guess, because this will just look like a scope, and this now looks like a struct, like literal. It's constructing a struct, not a map. Yeah, you know, like what I mean. So basically, I like even about the functions. Scope.f right now is still unnamed, but I can have this to be named to scope.f. So how would I go about this? How do I know that the name is this? How does Zig do stuff? Let's ask ChatGPT. How does Zig figure out the names of types if they are anonymous? So type inference and type identity. Zig can infer the identity of an anonymous type using the type system itself. For example, point is struct. This creates named type. Yes. But you could also say const point is struct this. In this case, the struct is anonymous. Yes. But it still has a unique identity in the compiler. Yes. I can use Zig's built-in type name to get the compiler generated name of any type, even an anonymous one. How Zig internally handles this? This compiler represents each anonymous type as a distinct compile time object, often tied in a source location. You can assign it to a variable and treat it like any type. You can use it doesn't tell how it's doing it. I'm from F# land, so there is definitely a crossover. Nice. I don't know how F sharp does record. F sharp records. Let me see. Records in F sharp. We can look how they do it. Yeah, I guess. Wait. So, I mean, this is a special like. F sharp does not have dependent types, right? F sharp dependent types. Or something. You cannot dependent types for F sharp. Hold on. What is this? Or is it like a library? Type when. I mean, this is just like the generic arguments. Wait, what is this? Is this subtyping? Mm. Two types I mostly use on anonymous records. So in F sharp, when you say type customer, be this. Is customer an anonymous type like this? Or is this named? And this is a structure. Oh yeah. Okay. So this is the difference, right? Right. This is anonymous, and this is like a named struct point. Is that the difference with like this annotation? Mm -hmm. They also use the equal sign here, but the colon for typing. Okay. You can specify the full path here. Point.x. Because this is ambiguous. Yes. The labels of the most recently declared type. It'll do that. So by default, you use the most recent defined one, like in OCaml. I hate that. But you can explicitly specify the type, like so. Sure. Why am I looking at this here? Sure. Nothing unusual there, I think. All right. How? Like, what should so like? Shouldn't the name of the type depend on where am I looking at it, right? Like, imagine in Rust. Let's take a look at Rust. Play.rustlang. Like, we have seen this error message in Zig, right? So over here it says test module list result. It spells the full type. What if I do this in Rust? I have yeah, let's see. I have module foo, and then inside this module foo, I say struct foo, and then I say function main, and then I say let foo is 1 2 3. So the error message would be main function not found. Okay, sure. It's tried to compile it as a binary crate because it's so main. I think. So it says mismatch file. Yeah, see, it says expected foo found integer. So it's reporting the type, but not fully qualified. If I say this, if I have the same code, but I specify here foo colon foo, then wait, this is still not qualified. Why does Rust not specify the fully qualified name here? Isn't that weird? Because like in this scope, foo doesn't exist. Foo only exists like in namespace foo because I did not use it, right? So wouldn't this error message be better if they say expected foo : foo? If I say over here struct foo, and if I say foo is equal to foo, we will have, okay, so now it says expected foo found foo. So it only does that if the type just like foo exists in the current scope. Otherwise, it's not using this. Okay. They got that. They get got by that. You get got by that sometimes, where you don't know where the type is coming from. You type it and let LSP qualify it for me to find it. So they only do this if specifying just foo would make it like ambiguous because it exists in the current scope. But what if I had two modules? Hold on. What if I say goo foo, right? So that I have this other module that is called goo. Oh, it does that. Okay. But what if I call this foo2 and I call this foo2? Then it would just say foo. What if I had this struct foo here, struct foo, but I'm using the foo2 still? It still says expected foo, right? So, and now this is not obvious to me which type we need, because like in this source file we have two struct foos, right? So it only specifies the fully qualified name if the name of this type is the same, I guess. So wait, hold on a second. So you're also saying that if I have here struct foo2, and if I say just foo2, then it will say expected foo. But that's not what we expect. Oh wait, hold on, no. Hold on, struct foo. Yeah, there we go. Look at this. This error message is bad now. So we expected foo, found foo2. But we don't expect foo. Foo is a different type. Foo is like in the root module. We actually expect foo : foo. So, like, judging by this error message, I would like just replace this with foo, but I still will, like, this will not actually fix. Now we expect foo. Okay. I'm just thinking, what should I do? So Zig always specifies the fully qualified language. Rust only qualifies it if the type names that are expected and like the actual types are named the same. Only then it like qualifies it. So I get, so right now for like this, that's about types, but the functions are kind of the same, right? Functions are kind of the same. Right now for functions, have name, which is just a symbol, right? But a name is actually not just a symbol. A name is a full path, and path can contain like function invocations, because it's like a generic type. Why define a type name without definition? Wait, what do you mean? Why define a type name without definition? Where? In the error message or where? I think in the error message you don't want to see the definition of the type. No, this over here you want to just have the names. Yes. Oh, you mean like no, this is just how it's done in Rust. I guess you're not familiar with Rust. This is just this is like a unit struct, which is basically struct with no fields, kind of similar to this, just a shorthand. The same thing. So you have like you have normal structs, but you also can have tuple structs, which look like tuples but like named, you know, like this. Or you can have the same as units, which only have a name. So it's like a zero-sized type, which doesn't have any data inside. So it kind of only exists at compile time. Useful as a marker, yeah. So the name of a function and the name of a type should be not just a name. It should be a path. Okay, so right now I'm saying name if needed. So name if needed is called when I am. So I'm naming things. I'm naming values, right? When I am assigning a value to a symbol. So when I'm saying let x be y, if y is something that is right now anonymous and needs to be named, I will name it, right? But how do I figure out the path? Like the fully qualified path. So when we're talking about paths, it's about and also like cannot like isn't it possible to have multiple paths to the same type? Right? So let's say that over here I have a type list, right? Let's say that I have a module 2, const module 2 is a struct where where I would have a type alias, right? So like function list. I guess this is the same as I already tried. If I have a comp time t type and I return module.list t, and then over here I'm using module 2 list something. This will say so the type is still module, not module 2, right? But if this module is like internal module, right? This is like implementation detail of module 2, like so. Should this path even be this dot list, I guess? Like shouldn't, yeah. So this says test module 2 module, but like this is internal thing. So I would kind of like this to be reported as just module 2.list. The language is sick. Did you try chicken noodle soup? Hello Bigorli, and hello Lanky Moose Codes. Because like if this is the internal implementation detail of module 2, then I don't want it to be present in my error messages, right? What does Rust do with that? Let me see. Let's try Rust. We will have the same thing. So foo is foo, which is different. But then I have module goo inside module foo, and I have, instead of this struct foo, we just say pub type foo is goo foo. What is going to be my error message here?
Expected goo foo. By the way, look at this. So they don't like, so goo is not even like, goo is not even accessible in this scope once again, right? So the fully qualified path here is foo colon colon goo colon colon foo, right? Let's just call them A and B instead. So I expected B foo, but B is not even available here. I cannot even say this, right? But what if I have another module called B over here with a struct foo? Then it will say the fully qualified name. Okay, so it literally is trying. Wait a second. So why are they doing this here? How is this example different? This is weird a little bit. How is this example different from foo2? Because this will say that I'm expecting foo, right? But foo is available in the current scope. How exactly are they figuring out how to qualify this? If I say that this is a foo, then it will say I mean that's the same, right? Like if this doesn't exist, then they say just wait. Now they say A B foo. Oh, wait a second. It's because just module B exists, I guess. Wait, so it's based on the existence of modules, but based on the existence of types, we don't do this? So only modules like lead to qualifying the names? Like if this is just called B2, then it will say over here just B foo, right? You see what I'm talking about here? Like, so it's trying to just report B foo, but it sees that B is a module that already exists, so it qualifies it even further as a B foo. But it does not do that if this is not a module that is conflicting, but a type, like this. It will still just say foo, even although we know that the foo is existing here. What if I had the module foo? I cannot have a module and a type, right? So it only like works for like it only like looks at the conflicts for the paths, not for the final type name, because this is a type and this is a module, so it's like different. Okay. Okay. Naming, like figuring out the names is not that easy, I guess. So, let me think. One node B is still accessible to root module. Can you try with side modules, like having AB foo and then use it in module B and not root? So you want this, but try to have this this error message over here instead. So we want like this is fully qualifying it, right? Like saying AB foo, but if I try to do this inside module A, let's just try like super foo, I guess. Actually, look at this. It says still expected AB foo. It's wait, what? You want to assign module B outside module A? I mean, this is also like a little weird to me because over here, like A doesn't even exist, right? I cannot say A, B, foo here at all because A is undefined here. If we do this inside module B, this would be so instead of foo, I need like super A foo. I guess something like that. But what if all of this exists inside a module? What if all of this exists inside a module? Like so. What is the error message going to be? Is it going to say module AB? No, it still says just AB. Wait, hold on. Hold on. It says expected AB foo found module foo. So it doesn't say expected module AB foo. It's weird. All right, let's not look at Rust, I guess. So Zig, on the other hand, just does the full path always. The only thing that I didn't like about Zig, that I don't like about Zig here, is that it says module.list.result. It doesn't include the arguments here. While if I don't assign this to a variable like this, and I just return the anonymous struct directly, struct value t, right? If I do this directly here, then we will see like a list with arguments i32, right? But if I assign this to a variable inside this function, then I don't see the arguments used anymore. That's the only problem with Zig, in my opinion, here. See, the list is like not being called anymore. Does iosd mean anything to you? What's iosd? What are you talking about? So maybe it is better to have these the way it works in Zig. What if there was like a fail-safe at the very end where the error message string gets generated? If the two types end up generating the same string, you go into max verbose mode and spout everything you got. I think it's better, like, I think we should start by figuring out the fully qualified names. Because, like, simplifying the error messages, I guess, by, I guess it should like be simplifying the error messages instead of like qualifying them if they are in conflict. But instead should like simplify, not like what's it called? Not qualify. And they're still the same. You add sorry to the message. Okay, so how do we figure out the fully qualified name, right? So, so I think I know how actually. I think I know actually the solution here. So you know that this symbol exists. The symbols, they don't just exist on their own. They always exist inside a scope. So when I say list int32, I want to know what is my parent scope name, I guess, right? That's what I want. What is my parent scope name? When I'm compiling this code, my parent scope name is not known yet. But as soon as I assign the parent scope to a variable, this scope becomes named. So I should have names to scopes, I think. That's how we implement it. Yes. That's what I should do. I should have scope names. Yes, yes. That makes sense, right? So we have scope here. And scope only has ID right now. It has parents, right? So that symbol should know the scope in which it is defined. And when I assign the name to a scope, we basically know the qualified name. Is that it? So similar to functions, they only had IDs before. Now we have name. Question marks? CFG338. Are you question marking me? What am I meaning? Or somebody else? What if no. How can they still be the same name when you include file name, line, column? Oh, we can include line name, line, column instead of qualifying. Wait a second. Wait. What if? Yeah. Hold on a second. I think DevNinja is onto something here. When scopes had names, they had a name in Zig. So scope is a struct. I do the same thing for myself. I am very similar to Zig in this sense. So you see how they called struct? So basically a list in 32, or like a function list. This means that a list is actually a field in this struct. It's like a static field. So yeah. So when you say module.list like this is actually getting the field list of this module. But like since we're not constructing the like the instance of the struct, it's like the static field. Okay? And I'm doing it the same way. But yeah, what if we do it literally the way DevNinja does it? So I know where the symbol is being defined, right? I know where the symbol is being defined. I guess I don't really know, but I can have the span information here. Where is the symbol coming from? Span. We do have spans. Proc macro spans. Macro should expand before the error message is generated. You cannot give people the line numbers after expansion. Namespaces, aka modules. Well, I mean, a namespace is basically a struct that cannot be instantiated, that only has static fields. The reason it's done like that is because so the language that I'm making, just so that you know, we have the reason it's very similar to Zig is because I have comp time, which means that the compiler is the interpreter. So we are interpreting this code. So a namespace is literally nothing different as just a struct with fields that exists at compile time. I don't know if that made any sense to you. But like we don't need a namespace as a dedicated feature in the language, because a namespace is just a struct with fields. We just use that struct only at compile time. If I have the span information here, Raymarch, you say like just the span is not enough to disambiguate? I think we still want the fully qualified name. Like figuring out the qualified name, like even like the span information is like an additional thing so that I know where, like, I guess in the error message we can include where the type is defined, right? When we say expected A B foo, they actually have it here, right? So like module foo is defined here, and like AB foo is defined over here. So like they have this this information too, right? This is where it is defined. So I want to know both the name and the span where it is defined. I want to know both to have this error message. Spam every info you got. Yeah, we need both. Let's have the span information first on my symbols. So when I'm creating a symbol, I should have a span so that we know where it came from. Right? That makes sense. So now I need to just make sure that I initialize them everywhere. For example, over here, I have a namespace. Local symbol new name. Name is a string. Namespace into values. Oh, this is when I'm using. So when I say use std.star, I'm importing all the symbols. So does this mean that so I have tuples. And tuples have named fields, but the named fields, they only have string information here. But if I'm importing them, I should still know where they are defined, so a string is not enough. So a tuple should be named based on not just strings, but based on identifier, but based on symbols too. Yeah. Hold on, this complicates things a little bit. But it also means that that it will be like faster to get. No, hold on. Where's the symbol defined? Symbol. Wait, do I have two symbols? No, this has just been used. So symbol is defined here, but it should instead be defined somewhere else. Tuple is like in this library utility, which doesn't know about ASTs yet. But spans, they are defined in the AST. Or should I make a tuple which should work, like, if this is working as a library, then I should have like the key which is like something string-like, right? Which I can borrow the string from. So this should be more generic here, so that it works with symbols. Maybe. Let's just not have this yet. Hold on. There's a lot of work, it seems, to do this simple, adding the span information. Let's just say over here the span is going to be the span of the use macro. So like if I used int32, if I used std star, then int32, when I use it, it will look like it's defined on the use statement instead of the actual standard library. But I will just have a to do here. So I just say span think I need to clone it to do actual original span is needed here. Okay, so just one of the examples. Over here we have a binding. So we have the pattern, which is an identifier. So I know that this is the AST, so the span is literally just here. Yeah, name at span. Yeah. Sure. When I'm compiling an expression and I know that there is a syntax definition, this over here would also be data span clone. Sure. If I register a function, what is this? This is interpreter registering a function. This is a Rusty function. Yeah. So this is defined inside the Rust code. So the span would be something like 00, where the file name is like a Rust code. I guess like this can be passed to register in a function, so that we know, like, this is basically for using the language as an embedded scripting language. So we can pass over here the information where the function is defined in the Rust code, I guess. Rust code. But yeah, maybe we want here have span as argument. Expect position. Yeah. This is going to be a position. Position. Is there no constructors for the start? I just have all zeros here. Good enough. So if it's in Rust code, we just don't know the line numbers at all. So yeah, over here, if I use the thing, symbol new name, so I do have this data. It's not going to be ignored anymore. We just say data span clone, and like this is the same thing to do. Actual original span. Okay. This is generating a symbol. So we can generate a symbol. If I generate a symbol, then the span of this should be the code which called the function, right? To generate a symbol. But do I know the span where the function was called when I'm calling a function? Right now, I don't. So this would be a feature like in Rust, which tracks the caller, right? I need to track the caller. But I guess for now, I'm just going to do the same as for the Rust code. Let's do this. So I have this span. This is for the gen sim. We don't know where it is, but we have a to do. To do track caller span. Tracking a caller is a good feature anyway. Okay, there's more over here. So std. Yeah, so std is implicitly defined right now. Std itself is not defined anywhere, right? I guess it's defined as like the whole file, the whole standard library, right? So this is over here, the variable std path, right? So this is the path. I'm importing the std, and then the std itself is defined as the whole file. So std is defined in as this file, and so file name is the std path start. I think I will have position 0. Uh, 0, 0, 0. So when I'm inserting something into the compiler scope, this has a name, but I also need a span here. Like, where is this name coming from, right? Name span. Compiler scope. Binding symbol name. Binding symbol span. How come that Kuvi uses a real IDE? Hold on a second. You're right. How come? Let's use the real thing. You're right. I don't know why I opened VS Code. I mean, it's nice sometimes. Sometimes it's nice. Span is private. This should be public. This should be public. This should be public. Just have everything public. It's fine. Yeah, I guess like I really like the way the integrated terminal is working in my new Vim. It's not like half of the screen, but basically like the full screen. I guess I could have it in a separate window. Build span is private. No, it's not private. Use Hyperland grouped windows and Alt tab for my terminal. Yeah. I mean, I'm not like splitting the thing into groups like this, so I can make a fake full screen like this. But then, wait, how if I have like the fake full screen window like this? I think there is also a way to Alt tab. This is like similar to groups, kind of. Down. Swallow language is different. Yeah, I mean, it is a little bit different. I just don't like seeing the tab names above, I guess. Like, I disabled my tabs even for VS Code. Damn, you can probably hide it. Yeah, you did hide it yourself, yeah. Yeah, they look ugly in Hyperland if you don't hide them. At least in the default configuration, maybe you can customize them, no idea. This, inject bindings. We have a binding, span, binding symbol, span. And then this thing over here, add a local. Name, symbol span. Is that it? Maybe that's it. So now when I have a name, right? I have a function. Let's see, value. I want to have a function. And I want to have display for function. So like I'm over here, I'm showing the name, but I want to show the name span, right? So name at the span. Name dot span. Is that how I do it? Main to 1. Yeah, over here also fail to evaluate the file. This is going to be, I guess, the same where we do span. Start is position. No. Position 0. And is position 0. And file name is path. Clone. In Rust, the collision problem is only resolved at the very last moment when the code is expanded. Otherwise, there is always ways for the spans to be the same. Yeah. All right, let's see here. So if I have function print, that we know, look at this. So we know that the function print is not just, it's not just a function print. It's function print, which is defined in this file, line 64, column 7. Right, so I can have this. Wait, how do you like? I guess this is something that I don't know how to do in NeoVim still. How do I go to this file? Because if I was in my VS Code, I can just click on this thing, which is just so easy. Maybe we go back to VS Code. We go just to REPL. I didn't reload the thing immediately. So if I have print, then we know that this is defined over here, and I can just go here. I should not start with that. And I guess VS Code doesn't... Like, I'm showing the entire span here, but this is where I should go. There we go. This is the print. Use F12. You mean you use F12 in the NeoVim to go to the line under the cursor? Something. But like it also should close the terminal, right? It should open it in a different, not in like in the current window, which is the floating terminal. So VS Code thinks that all of this is the same thing. I'm using this like symbol to specify the full span, so like it's like the print is not just in a single place, right? It's like this whole selection. Is there a standardized way to do the selection instead of like this symbol? And also, why does it think that the at is the thing? I should just say at then, right? At. Over here, this should just say like at. Oh, in VS Code you press F12? Wait, I mean the line is in the terminal, right? I guess you can press F12 if the thing is like in code like this, maybe. 12. No, F12 is go to type definition. Or maybe you bound it. Does Vim have make, CN, and CP? Is this like documented somewhere? Like I guess for going for VS Code is better. Maybe because more people use it than Vim, right? So yeah, there you go. It's a function print which is defined at this thing. Wait a second. Now it is doing it properly. So now it is not highlighting this. It's because I said at without instead of a symbol at. So now I can just go to the print like this. So inside the interpreter, I say like std.readLine, and it's this function which is defined over here, right? I can do std operator binary plus, and it is this function over here. Okay. I mean, this works. Okay. This is maybe a little bit too, like, I don't know. I kind of want this maybe like, I don't know. It depends if I want this to be printed or not. But this is good to have the information. All right, span information for symbols. Okay, so we have the span. And then we also want the full path, right? So this should not be just a read line. This should be std.readline. Because this over here is a symbol. So the symbol we know symbol. I know that the symbol has the span, but I also want to know in which scope it was defined. Scope? Because we are always inside a scope, of course. What's a scope? We have scopes. I have not a single scope. I have the interpreter scope and the compiler scope. And so I guess it's about the compiler scope, kind of. So when I say wait, but what if a scope is unnamed? We can have anonymous scopes too. What if I do this in Zig? Let me see. So this right now says test module 2 module list result. So what if over here I return? I have like, do they have in Zig like blocks like this? Then it is unused local constant because this only exists in this scope. But can I Can I return something that is calculated inside the scope like this? We don't do this in Zig, right? You always have a variable. But I'm just saying, so like if this over here is going to be result, and I return result, and I do this inside the scope, like so, does this change anything? This is still is a result, right? What if I say over here, const result is 1, 2, 3? This shadows the variable, but if this happens inside of another scope, if this happens inside of another scope, then like this error message also is not that good anymore, because we have two results inside this function, and to which one we are actually referring is not super obvious. Oh, we can break from the block with this? Yeah, so like, okay, let's say that I have like the named block. We have block, and then I break block with result. And then I just return this thing, right? So it does not include the block name in the error message. I mean, should it? I don't know. Like I just showed the example where it would be ambiguous, right? Because we have the another scope here with result variable. So this is where the span information is useful, for sure. Note, struct declared here. Yeah. Okay. Oh, wait, hold on. So, yeah, like, wait, hold on. It's unknown. Wait a second. Struct is declared here. Yeah. So struct is declared here. It's not like over here. It's not the result, right? The span information here is actually showing me not the span of the symbol, but the span of this anonymous struct. So this means that when I'm creating a function, we know a name of it. Like, look at this. We have a function. Let's undo this for now. I can go for function, and function has a name, but we also should know where, like the function, even if it is unnamed, we still know where it is defined, right? Just like closures in Rust, we know, like we get like the span instead of a name, right? So if there's no name, I should not show the ID actually, right? Yeah. So if I go to REPL and I say, and if I say just have me this anonymous function, they just say it says a function ID. But ID doesn't, like, ID is not useful information for the user anyway. I should instead have the span where the function was actually defined. Right? Yes. That's right. So this would be at span. So and this span should be like my span. And this would be like unnamed at span. Something like this. So the function can have a name or it cannot have a name, but it always has a span where it is defined. So when I'm initializing the expression function, I say that the span is the span, right? I have this data here. So I have a data span clone. Zig type functions become distinct if they have different parameters. Yeah, I know. Same for me. Foo1 and Foo2 are different. Oh wait, they become different if they have different parameters. Wait, hold on. Foo1 and foo2 are different only if n is used. Is that true? Let me see. Right here. So I can have a const foo is no, not const, right? It's a function foo comp time t type. So you're saying if I don't use the t here, I'm returning struct where like value is just an integer, right? So I'm not using the type here. Does this mean that it's going to be the same? That's what you're saying? Can I not have function inside functions? I thought I can. So we just unuse it, and then I say const x foo I32 is y, where y is foo I64, where value is 1, 2, 3. Wait, this works. Yes. Okay, I don't like this. I don't like this. This is going to be different for me. This for me is going to be different in my language. Why is it like that? Is there any reason? Is this on purpose? Doing well, thank you. Hello. Is this on purpose? This is like... Okay, but what if I say that this over here... hold on. What if I say just that this is 1, 2, 3? What is this going to be? It says test foo I32, right? It even includes this in the name of the type, even although this type doesn't matter. Pretty sure it's on purpose, but I don't know why. Like then you shouldn't include this argument in the name of the type if it doesn't matter, right? This is weird. I don't know what's their reason. ChatGPT. Why in Zig, if a generic type doesn't actually use the type argument, then types are same? Wait a second. So wait a second. So like in this case, I actually did not use it at all, right? But what if I said this? What if I said this? If t is equal to int32, then we return that. Otherwise, we return that. How is this going to work? Oh, you need parentheses? Stupid language. Is this going to work then? Now it is expected foo I32, but it is I64. So it literally matters if you like. It's not like in the final struct definition. If it is if it was used anywhere. What's the actual like? Okay, okay, sure. Sure. All right, I need a span over here. Span, data span, clone. What's the criteria? Yeah. Like the criteria is literally if it's used or not. I thought it's just like um every invocation is just being basically cached based on its argument, but it's not exactly like that because like Zig is a lazy language. On the comp time, it's a little different than my language here. My language is async. It's not lazy. So if I have a print, then this is a print function which is defined over here. So now this over here, this span is pointing me to where the function is defined, not to the name of the print, right? And if I say an anonymous function, that this is an anonymous function that was defined in the standard library line 1, right? You reach 666 grabs. Nice, Nertzl. Nice. So now even like the anonymous functions, we still know where they are defined, which is good. Okay. Okay, all right. Spans of in addition symbols. Okay, and then we want the full path. So print should say not just print, it should say std print. Okay. How do I do that? So my symbol should have a name, should have a span, and should have the scope where it was defined. But the scope where it was defined is potentially unnamed. So like over here, this over here is an unnamed scope. So I guess in like our path of the scopes which we go through, we just skip the unnamed ones, and that's what we report as the final like thing. Yeah. So symbol should not just be created. This should always exist inside a scope. So a scope is the thing that is generating symbols, right? This freestanding constructor doesn't make sense. We should create a scope we should create spans inside scopes always. So this should be a method of a scope or something. And scope is just scope. Or is it scopes? Is weak. Bam, bam. We have ID. And like scopes should also have names. This scope, this one. No, I need scope here, yeah. Not scopes, I think. But scope is not... Scopes. A scope is just not imported. I mean, yeah, it's like a private API. Okay, So I mean, wait. So the symbols, are they always referring to the compiler scopes or not? Because I have the generate symbol function, which generates a new scope. Like the reason for the gen sim function is because of the thing. I guess we have this example in the in one of the derived macros in Rust in this code base. Look at this over here. So I'm creating a new identifier. Like this. And why is this identifier having this name? The reason is I don't want it to collide. But it's used as a function argument here. And this. Wait, do I not just do... Why am I even doing this here? Shouldn't I just call the diff... the... Oh, wait, there's mixed side and... Yeah. There's mixed side still. Oh, it's because, like, I'm still using the identifiers. Like that. Why did I need to do this? Like, because it can collide. Is mixed site new? Mixed site is always there because what's they are like they're supposed to have the call site, but call site is oh wait, is it actually working? I thought call site was not possible yet. No, the definition side is not possible. Def site. It's supposed to be not mixed site, but definition site. But Rust doesn't have this. Right. So this is the alternative of the definition site. I guess the reason is because I am generating the symbols maybe here, like I'm pattern matching the thing, and it might have the same name here. So for the names to not collide, I'm making this random name because I can have a field with the same name. Let's just see what happens to this code if I don't do this. What if this is just going to be called F? Is this going to not compile anymore? Maybe I don't have a field F. Let me see. Scopes. No, this is the deriving expression display. So expression display is used for the expression. Like, let's say that it is a left-hand side, for example, and what's going to happen if I call this left-hand side? It still works. Okay, why did I need to do that then? I don't remember. But this is still useful sometimes, right? So we just want to generate a unique identifier sometimes when generating code. Does Sin have something for this? Sin ident. Like, I want to guarantee that it is a unique one. I guess, like, I guess what happens is if I, like, let's say that I generate new to, like, yeah, I guess, like, I need to generate more stuff for this to be conflicting, right? You have an example, Nurtle, maybe? Or did you never need to do this? I don't remember. I'm not listening? Alright, never mind, done. Are you working on your game? Okay, anyway, so we have the scope where the symbol is being defined. And making a symbol, generating a symbol, needs to be happening in the scope. Is it a compiler scope? Maybe it is a compiler scope that I need. Compiler scope does not implement debug. Do I need debug here? I probably do. Okay, we just do implement std fmt debug symbol. I guess like we have the same thing where like debug is just showing the name plus the span, maybe. Do that. Never calling the debugs though. I think probably can remove this. So now I'm missing scope, right? So symbol new, we should not have this method at all. Instead, we have the compiler scope, and the compiler scope should have a method new symbol, which has a name, has a span. Is this what I want? And then scope is self-clone. Name into. Why is there two intos? Okay, what is name? It's an argster. Simple into string. Sure. Okay, so now I just need to see where am my... So instead of doing symbol new, we're doing cast scopes compiler new symbol, right? We generate new symbol and the current compiler scope. Compile ident pattern symbol new. Cast scopes compiler new symbol. Cast scopes compiler new symbol. Register function. I think it's the same. Although I'm not sure if this is... maybe. New normal. Test. Oops. Compiler. New symbol. Maybe I should just have like new symbol as a method on cast directly. Then yeah, it would make sense probably. Compiler scope. This would be just self new symbol. Because when is this even being used? Whatever. Scopes are a little weird. I'll need to check that at some time. That it's all correct. It's weird because like I have like hygiene and stuff for macros. And local self. Oops, compiler symbol. So this over here, right? GenSim, this should generate it not in the current scope because the current scope is the scope. Right, like, oh wait, hold on. I have the parent information, right? Because I have scopes and I have parents. Because, so this is like the caller scope is actually the parent, but I only have the parent interpreter scope, not the compiler scope. It's a little different. I need to track the parent compiler scope. Something. Subcast here. Cast, scopes, compiler, new symbol. All right. This over here needs to be cast. Okay, now I have the scopes, and I can so I have the scopes. Scopes have parents. So, and now if I give names to scopes, then I can I can like qualify the paths over here too. Cast, let's just have this cast new symbol. Import include public function new symbol elf well self scopes compiler symbol name enter string span like so. Sure. Let's look for this. And we just do that everywhere. We have, yeah, we're only always going through this method. Why not? Cerebral cast is immutable because it all also is being. Wait, hold on, over here. Yeah, okay, sure. I need to first now make the symbol. Is that? All right. Everything still works. std print is still a function print defined here, but we now need names for scopes. So symbols know the scope where they are defined, but scopes don't know about their own names. So I should have name, which would be mutex option. Okay, but should the name here be a symbol? Or a string? I think I can just do symbols. But that means like I can go through parents, or like I can go to the symbol scope where the symbol is defined, and that's the same as the parent scope, kind of. Maybe, I don't know. Let's see what this is going to give me. So when I just create a new scope, it is always anonymous. Right? But then I have a function name if needed, same as for like my functions, where name is a symbol. And I say let a like self name is self name log unwrap, and then if self name is none, then self name is some name, like this. So compiler scope is the one that has the names, right? So public function name if needed, self name symbol, self zero name if needed, name. Hello, Robert Pattinson. Hi. And then when do I name the compiler scope? This is when this scope is assigned to a variable, right? So, and I'm assigning the variables always inside some other scopes. So over here, when I insert it into the local, we say name value if needed, when I assign value to the symbol. So value, so a value can be a function, but std, standard library, is actually just a tuple. So a tuple should have the actual names inside. So this should not be just a tuple like of places, of values. Inner, I guess is what I call it. This should also, so a tuple value is potentially also named, I guess. Perelman, hello, hello. So name here is an optional, is a, or Spark Mutex. Draco Java Malfoy. What? Hello, Veldak. Mutex symbol option. Like, I guess if I use this in multiple places, then maybe I should like have a thing for it. Today I'm working on my programming language over here on the right. You can see I'm working on Cast. Cast is my programming language. I'm trying to add names to things. So I have names for functions now, and now I'm adding names to scopes, which will allow me to have fully qualified names. So like function f is not just function named f, because it always exists in some scope, right? Like there are some functions that exist in standard library, so the full name should be std dot some function instead of just the function name. That's what I'm doing right now. And then we also need to name the types, because before today everything in this language was anonymous. Self inner. Yeah, let's have this Spark Mutex option. Symbol. Is there just two of these? Oh wait, why is it even in a park? Oh, because it's yeah, for cloning. Wait, but if I clone the struct, should it even be the same one? Or should I just clone it? So I have a job now, but I don't have enough money to sustain myself to the next payment. What do I do? I don't know, you borrow money from someone else, I guess? Is my language compiled to binary? No. I mean, not yet. Not yet. Yeah, we have like this website. We're just talking about things a little bit. But the main idea is that the language needs to be interpreted, because the compiler needs an interpreter. Once we once we need the compiler to compile to binary, we still need the interpreter, because we want to be able to evaluate code at compile time, similar to Zig, or I don't know, const evaluation in like C++, Rust. I don't know. So we need to be able to evaluate code at compile time, which means that we need an interpreter anyway. So it's supposed to be both interpreted and compiled language. Where a compiler would be just implemented as a library, kind of implementable at least. Maybe we'll have like an embedded, like the included compiler, but you should be able to write your own compiler is the idea. That idea is kind of like rough, but we want to have something like this, where we have a function written in cast, which is like a vertex shader, and I should be able to transpile this function to an actual shading language, right? So this transpiler is supposed to be implementable as a library, and then we also like actually build our game into a binary with another compiler. So like in the same code, I want to be able to like compile my code to multiple different targets at the same time, and also like and this so but this basically means that the compiler is the interpreter. Does that make sense? So it's a language with very powerful compile time evaluation, which basically means that the compiler is the interpreter, which means that we have the interpreter. I do have, like, you can see over here, I have the compiler scope and something that I was just looking at, But right now I am compiling my code into a very, very high level representation. So I call this over here the intermediate representation. But basically, the thing that I'm compiling into is like you can just call this the AST, I guess, instead of the intermediate representation. But it doesn't only have like the syntax information. This also has already like the type inference data and like other stuff, right? So it's not just in the syntactic tree, but it is just very, very high level inner representation, which we will then lower further into like assembly and stuff. But this is not there yet. Like I think before making a proper compiler, I will want to maybe try making my interpreter JITable. So use something yeah, like so that the interpreter is like faster, because it's relatively slow right now. I want it to be JITed. So it's not, but I don't think it's going to be LLVM. My current plan would be to go for crane lift. As far as I know, it is a little slower than LLVM, but it is just easier to use. It is able to do the JIT, it is able to compile to native. LLVM probably is just like it is better if I wanted to target like a faster binary, but it's not really like the goal for me right now. I just want to be fast enough, I guess, which is CraneLift is supposed to give me. And also, I really want my code to run in the browser, so I think the first compiler is actually going to be a transpiler into JavaScript, not even into WebAssembly, but into actually JavaScript, I think. I don't have any backends, so like the language was originally made in OCaml, and I had a proof of concept, a JavaScript transpiler, which could run the hello world, but which could transpile a hello world, basically. I think we still have it. I don't know how to, I don't remember how to run it though. But I could transpile a hello world into JavaScript before. There's a QBE. What is QBE? Compiler backend. Is this like better? For some reason than LLVM and CraneLift? QBE is a compiler that aims to provide 7% of the performance of industrial level 1 compilers in 10% of the code. Okay, yeah. So like what? Is it like more high level? Just so that it's like fast enough, basically. Uniform and simple SSA based intermediate language. Full support for the CABI. Yeah. I don't know. This website though looks older than the CraneLift one. Maybe. Where's the releases? 2024, 2023, 2022. So it was released in 2022. It's actually newer. All right. QBE versus CraneLift. But does QBE has like the Rust front end? Because I'm writing my language in Rust. Q in natural Rust data structures. QBE docs. Function new linkage public add. All right. I mean, this looks like it is totally safe too, right? And this looks pretty simple. We create blocks, we add instructions to them to return the value. Yeah, this looks like similar to how I am making my high level intermediate presentation, just a little lower level, I would assume. My selected one has more platforms than QBE. I mean, CraneLift has less platforms than the than LLVM. I don't think I care too much about a lot of different platforms. I just want my interpreter to be faster, so I want something that allows me to JIT. Wait, my actually original idea, since I wanted to transpile my language into JavaScript, my original idea was that in order to have, so like basically, ironically, if I want to have a JIT, because I still want to transpile my language into JavaScript, JavaScript already has a JIT, right? So I, instead of just-in-time compiling my code, I just-in-time transpile my code into JavaScript and then run it through Node.js or something, or like I guess I embed the JavaScript engine and do that. Yeah, that would be cursed, but that means that I only need to write one thing, which is the transpiler into JavaScript to begin with, right? Okay, what was I doing? So I have tuples should have names. So like, yeah. So a tuple for me is like a struct, which I should rename to struct, actually. This is literally the same as in Zig. So this over here is a struct, right? Like once this is being evaluated, this is still anonymous. But when I assign the struct to the module, this is where this becomes a named struct now, right? Yeah. So I just have the name for it here. Sure. Okay, in cast sense for cursed. Yeah. Guys, we start with this self.inner self.inner self.inner. Why cousin doesn't want to be legit language? What do you mean it doesn't? Aren't all the legit languages have the compiler and all the toy languages have the transpiler? No, cast wants to be legit language when it has both compiler and transpiler and interpreter and everything. I literally want it to be used for everything. Right now, it is kind of relatively usable for being used as an embedded scripted language, which it already been used. This message in chat is being spit out by the embedded cast in the bot. So that part is already working. Thank you for the bits. Yeah, I'm going for it. Yeah, we have like this is the source code of the bot, right? So we literally have the bot source code written in the cast language already. So when you type something in chat, this code over here is being ran. So if you type, for example, exclamation inc, it is going to increase the internal counter. And it's going to show the current value of the counter. But when do we get overlay crabs again? Yes, a little later. Okay. And we need to transpile into JavaScript for this. Wait a second. So I will have the... hold on a second. I want std to be named. Guys, just don't overflow, because then the bot is going to panic. Just don't go to like 2 billion, please. All right. Or the bot will panic. Will 0 value inner. Tuple value from tuple on place. Wait, what? Tuple value. Inner fields. Name. Yeah, so I want to have names. Name unknown. How about this? Let's have this name mutex option. I want this to be just a name. Thank you for spamming in chat. Hyperland Kek. All right, so what is a name? It's similar to the symbols. Let's have a module for it. Mod name. Do we just have a public struct name, which is just arg mutex option symbol. I guess. Simple name. So unnamed, unknown, or something, right? Is the constructor like this, and then we have just function name if needed. So we assign the symbol. So if this is none, then this is name. Some name clone. Like so. You definitely need to rate limit for your bot function. Yeah, maybe. But they stopped. They reached the nice number. So it's fine. It was a stress test. Thank you for stress testing. Name if needed. Okay, so we have name, lib, use a self name like so. Mutex option. And so maybe compiled function. And over here we have two names. Name if needed would be self name. Name if needed. Name. Name unknown. Tuple value name. Yes. So this should be just name unknown. This should be name unknown. Name unknown. This would be self name. Name. Yes. Name hash is not satisfied. Yeah. We derive hash partial ack. Sure. I guess I should just be able to write the name. So write f this at that, whereas we have self name and self span. So I need to be able to display the name, right? We just say impl std the display for name, which would be that code that I just deleted, right? Match self 0 log unwrap some name f name, and if this, then write underscore. And then this name unknown. Okay, so now that we have the name unknown, what does this give us? So now I have the tuples which are named. std is just a tuple and it has a name, but hold on a second. No. This is wrong. It's so I have a struct. So I'm generating this struct when I'm evaluating. Might be wrong. It's not exactly a tuple. Maybe like a namespace or I don't know. Let me think about it. So right now we have an expression which is called recursive expression. This is basically a struct. Maybe it should be called a struct, right? So we have any code inside, and basically all of the bindings from the body become the fields of the struct. That's how it works. Right? But this should be done Yeah, and then we do the interpretation. I think I should, yeah, so I look at the interpreter, and when I'm interpreting the recursive scope, so I'm entering into the recursive scope, right? So this is my scope. Inside the scope, I am evaluating it, and then I'm looking at all of the fields that got generated, and all of those fields become the fields of my, so like all of the locals that we have generated become the fields of my struct. So what I want is, so I have this scope here, and that should be the name. So this name should not be unknown. This name should be basically the name of the scope. Yes. Yes. This looks difficult. Yeah, it's a little weird to think about, but it's kind of the same. Like it's the same as in Zig. Look at Zig, right? So you have this struct, and then all of the, so like this const is basically introducing a new binding here, right? Why not sleep instead? Oh, instead of like making the language, yeah, I could sleep, I guess. But I am sleeping a lot, I would say. I'm sleeping, I don't know if more, like how do you guys sleep on average every day? I guess I started sleeping less lately, but I don't know, I was sleeping a lot, definitely, in the last, like, 10 years. Retro Mouse, hello. Like, I don't know what the numbers actually are. Oh, wait, hold on, I know how to get the numbers. I have it on my phone, right? I know how much I sleep. I'll tell you right now. So today I slept exactly 8 hours, actually. I expected it to be more than that, though. Okay, I mean, actually, average sleep duration of the last 7 days is exactly... So I'm sleeping exactly 8 hours later. Yeah, I'm having, like, a schedule. There was a long time when I didn't have any schedule, though. Do you have the information from, like, the past years? Let me see. A year. What about year 2024? Why does it so like this application? It shows me the average deep sleep and average light sleep. What is the average combined sleep? Oh, monthly. Wait, hold on. Monthly average sleep duration. 211 hours. It's like 211 hours a month. What's the average one a day? Okay, I mean, if I combine these together, it will be like around 8.5 hours. What about 2023? Also, yeah, in 2023, it was like 9 hours. In 2021, my average total sleep time was I need to add these numbers together. Hold on. It's 10 hours. Yeah, I started sleeping a little less lately, but I guess it's still fine. This looks like default hyperpanel. It's not exactly default. I changed some settings there. It's almost default though. You can sleep 3 times a day and the night. How do I know how much I have slept? So I have like this this band, right? If you have I don't know, the Apple Watch, I guess, or like, I mean, there's a lot of these things, right? I just have this cheap one. This is very old. I don't even know how old is this. This is Mi Band 4. Probably like 10 years old. Finally found a use for it. Usually just sits on my hand, on my like arm, right? But finally used it to look how much I sleep. There is another statistic, which is how much I walk, and that number is so that number is pretty low. I should walk more. Oh, look at this. My average heart rate today is 69 BPM. Is that a nice heart rate? So it's like lower when I'm sleeping, I see, yeah. Alright, anyway. So I think over here, when I'm converting a scope into a tuple, into a struct, the name is no longer unknown. The name is the same as the name of the scope. So we just over here say, instead of unknown, it is actually... well, I mean, it is still unknown, but we're going to when we are going to assign the name to this tuple, we're also going to automatically assign the name to the scope. So the name here is going to be inner scopes compiler name. Compiler scope. So I should have the name, public function name. Self should return name. Self 0 name. Like this. And then I clone it, I guess. Okay. So this should be assigning the names then. Why is that compiler? Wait, well, hold on. This is entering, and this is like doing that, doing this, doing that. This is the wrong scope though. Like, so what happens when I am seeing a struct? This is not the right compiler scope. Over here, I'm just using the interpreter, I think. So I need this scope be saved like around here, I think, inside the image representation itself. Why am I on VS Code? And why do we have the extreme typing animations? Why not? What should we be on? What do you like more? The Vim? Fine, let's go to Vim. If that's the abstract syntax tree, where's the concrete syntax tree? We do have the animations. I don't have the... This NeoVi doesn't have the, like... The screen shake, unfortunately. I would add it to my Vim for sure, if I can. We don't have, like, the concrete syntax... I mean, so I have the thing, which I call the AST, but it actually is the concrete syntax tree, I guess. It just doesn't has like all the information. I just should add the information to it. I think I might be like naming things a little wrong, but I have the AST. So this is the AST. This is the entire thing, right? So AST is either a simple token or a complex definition because we have custom syntax and stuff. I just should add like the white space so that I can recreate the source code as is. And I guess I'm not always like storing all the tokens of the complex definitions, only the inner values. But I can make this work as a concrete syntax tree, so maybe it should not be called AST. I don't know. Helix is Vim rewritten in Rust, right? No, not exactly. It's not Vim. It's a separate thing. Right. let's see. First of all, let's see this. I want when I am defining. So names have the symbols, right? And symbols have the scope in which they were defined. So the name, I can get the fully qualified name, is what I'm saying. So let's say over here, when I'm displaying the name, I want this to be fully qualified, right? So I want to write the name itself, but I also want to see if name dot scope let's see here. What am I working on exactly? I am working on my programming language called Cast, and I'm adding names to things. It's listed, is written over here. I guess I can like write more about this here. Cast is my programming language. Right? And I added names to things, which means like which means that, you know, like previously everything was anonymous, right? So I want to know names, like print's name is std print or something, right? I want to know fully qualified names. Something like that, if that makes sense. So my language is similar to Zig. If you just joined, here's the example from Zig. You have an anonymous struct, then you have this anonymous struct being assigned to a variable, and this is where the name actually gets known, right? And then this variable exists in this other struct, so the full name of this now is module.list_in32, and then this module is inside that module, so like it's the full name of this struct is module2.module.list_in32, and we want to have something similar. Names are also not always the symbols now that I am thinking, like, right? Like over here, when we have a generic type, this is a little different. But let's do this first. So we have a scope, and I want to show the path. So I want to like traverse the parent scopes here, I think. Yeah, let's do this. A show path of a name.scope or something. Show path f a name scope question mark. So function show path has a f std fmt formatter, and it has the scope, which is a compiler scope, std fmt result. So basically we say if scope name is known, right? There's two things. So this is the name. scope name is scope name log scope name 0 log unwrap if let some scope name is scope name, then we do I guess I can like get it cloned so that I'll unlock it immediately. Yeah, sure, why not? The scope name is an optional symbol now. So if this is sum, then I want to write scope name. What do I say? Like a dot here, I guess, instead of a colon, since this is my language, right? I'm gonna say okay here. We'll write that to path. But then this scope name is like the symbol, so I want to go and show the path of the scope name dot scope, right? We do that recursively like this. And if this scope does not have a name, then potentially our parent has a name. So else if let some parent be scope dot parent, and we show path of the parent. I guess otherwise we just don't do anything if this is the root. So what is a parent? This is a compiler scope. It's a little weird here. So parent should return optional. I guess also compiler scope, which means self 0 parent clone map self, something like this. Okay, now is this going to work? So parent returns an owned one because of reasons, but it's a reference counted thing, so it doesn't matter. Okay, let's see. Print. So this is just a function print because because the scope is wrong, like I said. So the reason it is wrong, so when I see a recursive scope like this, right, in code, this is being done twice. First, we need to compile this, and then we need to interpret this, right? So a standard library, it is first being compiled, and then it is being interpreted. So we have like const something, const x be 0, for example, right? So this is compiling it, and during the compilation we have the compiler scope. When then we are evaluating this, we have the interpreter scope. We still have the compiler scope, but we are basically like not using it. It's a little weird the way I'm doing it. But yeah, so I need to save the scope that existed during compilation in the intermediate presentation, I guess. So our recursive scope doesn't only have the body, but I also need to save the scope that existed. So scope compiler scope is just a compiler scope here. I need to know what it is. So when I am compiling the scope, yeah, I call it recursive, but this is literally the struct definition. I need to fix my namings too. So scope, compiler scope is basically the inner scopes compiler clone. I save it here. Scopes compiler doesn't implement display. Expression macro display. Wait, can I derive macros expression display? Can I skip the displaying of things? Derive macros expression display. There is, yeah, display skip. So we just say over here display skip. Okay. So when I'm initializing a scope here, this is initializing the inference data and stuff. I just pass this as is. Then over here, when I'm evaluating, we have this compiler scope that we saved, and I'm using not the new compiler scope, but the old compiler scope. Well, I guess I could just save the name. I don't need the entire scope to be saved, I just need its name. That's right. Yeah. You do only need name. I mean, let's just see if it works, and then if it works, then I just need the name here for sure. Compile faster. Stupid Rust. Is it linking? 34 seconds. Print. No, it didn't work. Oh wait, hold on. Did it work? Why does it say at? Hold on. Why does it say at twice? It says print at this and then at that. Which is completely wrong, which is like weird. So we do have two path elements here, I think. So standard library 64, 68, the 64.7, 64.12. Why is there a double at? Name. This over here does not contain any at. This is it, right? At span. But when span is being printed, we don't say at. Wait, why is it shown twice? What? We have standard library 64.7 and then 64.44. Let's go to standard library. 64.7 is basically the name of the print here. And then 64 is like just the definition. Yeah, this is it. And that's, so these are the two scopes that we saved. This one and that one. And the like this symbol. Okay. Why is there two ads? Because when I'm writing symbol, it also shows where the symbol is at. Okay. Okay, I understand. Yeah. So where is the symbol and where is the function definition itself? Yeah. I don't think we want for the symbol to actually have this. We just show the name. Oh, wait, no, in debug. Wait, hold on. In debug, we do this. Yeah. Where is the debugging of the symbol used? Self name. This is display. Let's do that instead. Can I see all the where am I using symbol with the debug formatting? I don't think Rust Analyzer can do that, right? This is just showing me all of the references of the debug trait. Function. Yeah, so like you see this over here. This displays it. Self name. Name. Yeah, over here. Over here, I'm using the debug. That's why we need to use the display. Yes. Okay. All right, so I did not assign the parent, the scope to anything, right? Print is this. Yeah. This is just print, not std print. What's wrong? Let's try this. Let A be rec. Let B is function, like this. So A is this, right? So we have a field B, which is a function named B, right? It's not a function named A.B. Why not? Why not? Why not? So I think what I can do, let's just do this over here. So when I'm showing the name, I want to always I want to always have the scopes. So if this over here, how about I write how about I write f, and instead of scope name, I say like my own ID or something, which is going to be scope.id. Right, because I need to see that I'm actually going through a bunch of scopes and they are all unnamed, I guess. Print. Yeah, so this is, yeah, there is literally a single parent scope with ID 398. How about this? When I'm assigning a name, up here, name if needed. How about this? Print assigned name. Just to make sure that I'm assigning the std, right? So I'm assigning all of these, and I don't see std being assigned. That's the problem. std is just not assigned at all. So std, the way it is being assigned, right? Std over here. No, not here. Std is over here, right? I'm making a new symbol. So I'm adding a local std. Call me Mr. Yogurt. Hello, hello. So I say add local. I have this std. Yes. Compiler insert. So std in this case is going to be a tuple, right? So if I inserting this over here, then this should be named std, right? Let me see. Print inserted name. right? Because like I should insert std as one of the last thing. You just joined and you're talking about std. Damn, see doctor. Yes, yeah, I inserted dbg char print. Where is my std? I want my std. Can a doctor fix my bug in the code that I don't have the std? So yeah, see, in order to create a new normal thing, we need to have the std. That's what's supposed to be there. I was trying to get std. Yeah. So I do add local compiler insert. Yeah, so this is saying inserting name into ID. And then I'm inserting. Oh, it's because it's a different symbol. Right. Is it? Wait. It doesn't matter. Is it? Insert into. STD. Wait, I did insert STD. Oh, wait a second. Hold on. I inserted STD. But then I insert some other things. Why? Because this is when I use STD. Yeah. Okay. Let me see. Just REPL pre-run this. Then the STD is yeah. Because like I by default when going to the REPL I'm using the full STD. So right now type is not defined, right? I need to STD type. Yes, that makes sense. So there you go. The STD was the last thing that I inserted. And if the STD was the last thing that I inserted, then what was the value of STD? You know about that vibe coding thing? Everyone's talking about it, and yet on Twitch, most programmers are not doing it. Do you think it's overhyped? The opposite are narrated? No, vibe coding is definitely not the thing that you should be doing, I think. But it's I guess you could have some fun doing some vibe coding. I mean, I could see you having some fun. I don't think it will be fun for me though. The wrong vibe. It will never be a thing. Do you think it will be a thing? No, I think it can be a thing, sure. Like a lot of the simple things can be coded by AI, sure. Can you vibe code a compiler for my language? You can try that. I don't think the AI will be able to do that, but I don't know. Maybe I'm just maybe it just needs to improve. Oh, a lot. Future engineers in the future will be called vibe checkers. Yeah. Why am I using Rust with a borrow checker? We can just be vibe checking instead. Anyway, so I'm inserting the thing for sure, right? And if I'm inserting the thing, then I'm saying name if needed. So I'm definitely naming the value. And the value is definitely not inferable. Oh, wait, it's because I never passed it, right? Over here, yeah, over here. If I have a tuple, there we go. It's because I forgot to have this thing here. Tuple value. If I have a tuple value, then I need tuple name if needed, name. That's what I need. Tuple is a tuple value. Expected value found a module tuple. Wait, what? Oh, it's because value. Yeah. That's what's needed. It's going to work right now. Look at this. Look at this. It's going to work first try. Oh shit, it didn't compile. Wait, tuple values have no name if needed. Value.name if needed. Sure. I can do that. Let's also remove the prints that I had. What I don't like is too high abstraction level and lack of some agency, but also much faster. Don't care that it needs less skill. I actually like coding and figuring things out. What do you mean much faster? You are saying that the vibe coding is much faster. Well, it depends what are your goals. It's faster at what? At like having the things. Look at this, print. Print is std print now. It works. It works. It works. Okay, so basically what this means, let's say that inside of std, let's just have like this example, just like in Zig. Or like what? Not like in Zig. I mean, yeah, sure. Let's have like in Zig, right? Names. Sure. Let's have this names. Use std star. So let's see. I want to have the so like here's the thing. Module 2 module, right? And stuff. So I want to have a module. Module is a keyword right now. So let's have a module mod, which is so I use this rect keyword right now, right? And then inside I have const f, which is a function, this, right? And then I just dbg mod.f, and it just knows automatically that it should be just run examples name, right? What's module? Module is just another so you know how like in Zig basically structs, like modules are structs. Struct module and like recursive thing is kind of like the same thing for me. So I should just get rid of some of these keywords and we should settle to something. It should be just called struct probably, just like in Zig. std syntax. So I have a rect keyword, right? Yeah. See, like this is just the alternative like syntax for struct. I can literally just say struct there. I just have like two syntaxes for it. There you go. So like this function is a mod.f, and then if I have like the inner, right? Like inner is a struct with this, right? Then we should have the name. So mod.inner.f, we should know its name. It should be mod inner f. There you go. What am I coding? I'm coding my own programming language. So that we don't... Yeah, we don't vibe code. We code the real code here. Yeah. So the name is not inferred based on like this fact, right? Like if I say f is mod inner f, or I guess I guess I can just say use mod star or something. Well, I mean this will only give me the inner, right? So I can say inner f. This is still mod inner f, right? Yeah, we can do this. Then I need just f. So f is just that mod inner f. We have the name. Okay, so this works right now, but only for functions. I can have function names now, but I don't have the type names. And also, speaking about the function names, I also want... So I want to have a generic function, right? Hello, Nigel. So I want to have a generic function, which means that if I have a like mod inner, and I have a function f, which is a for all t, you know, like for all t, let's just call this id, I guess, because that's what it's going to be. It's going to be a function x t into x, right? So this so f f int 32, for example, is going to be a function, not f, id, right? So id is a function. Wait, what? Why is it saying std this value? Wait, did I call something value? Maybe I called it value somewhere. Wait, why is it called value? And also I need to like get rid of the IDs, right? The IDs are not important. I don't want them. So this is std something something value. So I have two scopes inside std. Oh. Oh. Wait a second. Wait. How do I add code coloring to it? I don't have the code color. I mean, I have the code coloring in the REPL right now, right? Over here. This is done on based on the Lexer. It's not highlighting the keywords. I can see if it is correct token wise. It's the IP address of that type. Yeah. Okay, hold on. So the ID, for example, so ID is just the template mod inner ID, right? So template means that it's a generic. Maybe I should rename templates to generics. I don't know. And then ID, if I instantiate it, it's basically, so a template, it's like a function. So if I call this function with int32, this would be the same as like calling the function foo here with comp time t, right? But what does it say std value? That's weird. Where's the value coming from? Value. Somewhere in standard library. I mean, I don't have even any. Let's see here. Wait. What if I do this? What if I do this? Const f is that, and then I return f. So this is similar to how in Zig I made the struct, assign it to the result, and then I returned the result, right? So this should I don't think I can make this a constant data let. Yeah, there we go. So this is inner mod inner.f. So it's just missing the IDT here. That's what's missing. But why is this? Wait, hold on. Why is that? Giving me value. That's weird. I don't have any values. I think it's a bug. What if I don't use STD? I mean, it shouldn't matter at all, though. Yeah, why is this STD anything? Wait, there should not be anything about STD at all, right? There is nothing about STD here. You thought everything in cast was a value? Yeah, but like in this case, it's a name value. I don't name anything value, do I? I mean, in standard library, I do have some values, I guess. We can see here, value, right? So for example, over here, we have value being this. There was some values like here, but like none of these values matter, right? And I'm not using any macros, right? Let me see. If I go to REPL and if I say for all E, just have the unit function like this. Let f is this. So f is template f, and then f int 32 is a function which is unnamed. There you go. So like there is no std here, which is very weird. Is it if I have x t into x and then f int 32? This is still not having std. Yeah. What's the difference? Wait. Is the difference that, okay, if I have it const, it shouldn't matter at all here, yeah. So if I have then const mod is struct like this, then mod.f is mod f, and mod f int 32 is this. Yeah, see, like I don't have the std. What's the difference? Names. Let's get rid of this inner. I mean, let's just get rid of all of that. Let's have this. It's still std value. So like, how is this different? And what I tried in my REPL. So if I go into REPL and I say literally this, right? Const ID is for all the hold on. Let's just make this also unit into unit like this, so it just doesn't matter. Yeah, see, it still says std value. Why? Oh, wait, hold on. At example names 12. Yeah, okay. No, this is fine. This is where it is defined. In the future, normal people will wipe code and us masochists will continue to write our code ourselves. Okay, I mean, I can actually figure out where this value name is being defined. I can just like write instead of this span, the span of this like symbol, I guess, and I will know. But if I do literally the same thing in the REPL, right? So const ID is for all t that, and I say ID in 32. What if I say dbg? Oh, it's because it's saying dbg. That's why. That's the difference. Wait, why is dbg making any difference at all? So it's because dbg. So dbg in standard library is actually a macro, indeed. So dbg is over here. Yeah, dbg is for all t. Yeah. There you go. So we have a value, right? Yeah. There you go. So we have a value of this, right? So this means that when I am passing, when I'm passing an argument to the function dbg, I am assigning that value to the name value, right? And this name is defined in the standard library, which, so like this value, the full name for this is std value. That's correct. I mean, it's not exactly correct. I'm missing the generic like stuff, but yeah, this now makes sense. So what I need, I guess, like when I'm assigning something, when I'm putting something into a function, this should not set the names, right? It's only like for the let bindings, right? Although I guess the problem is that it was completely unnamed. That's the only problem. Like you know, here's another example, I guess. So if I have a REPL, right? I have a function, which is this, right? So this is an anonymous function, right? But then I have a function. You know, something that takes a function, right? So it's a function that takes a function, and then calls function with the empty argument. You know, so takes f is a function that takes a function and it calls it, right? So if I say takes function and then I call this with an empty function like so, right? Yeah, you know, like I can just like over here, I can debug the function that was passed in, like so. Yeah. So I say takes f with the closure inside. So because this closure that is unnamed, right? This is a lambda that is unnamed. I pass it as an argument, and the argument has the name f. Because the argument has the name f, it assigns the name f to the lambda. Is that not how it's supposed to work? What if let me try this in CAS in Zig. Try this in Zig. Something similar. So if I do this, if I have a function, foo, and this takes comp time t type. I just don't know how to like show the type though, right? But I guess I can do something like const x t is equal to 1 to 3, and it will only compile if x is like a number, right? So if I say foo with i32, then this will work, right? But if I say foo with struct, which is anonymous here, right, value i32, then yeah, then it says expected type test main struct 3389. Look at this. So this struct, it keeps being anonymous, but it knows that this anonymous struct is defined in the test main, right? So when you pass it as an argument, it does not mean that the name of this anonymous struct is t. So yeah, I think I know the problem here, but also like, but this also means, hold on, this makes it more complicated. So if I later say like const tt is t, right? And then I say t is tt, right? Because I am basically assigning this struct to a constant, right? I am doing it. Is this going to be called tt now? It's not. So I guess when you pass something as an argument to the function, like you lose the ability to assign names. When do you lose the ability to assign names? What if I have the unnamed thing? As a field. Well, if it's a field and it has a name, right? Which is the name of the field, and the parent is unknown. Do they need a name? Yeah, because you want to have like good error messages, at least. That's why you want to name them, right? I mean, you are assigning them to names over here. You construct a struct and you assign it to a name module 2 here, right? So it should become named. But in this case, I am assigning it to a variable named t, but it does not get the name t. So the difference is that this is an argument. So type name tt. Oh, you can just do type name. Oh, okay. Yeah, I just had this as like a compiler error, because that's the only way I knew it. So we just say type. Yeah, we have type name t or tt, whatever, right? And this gives me the string. And how do I print it? Std print zig compile log. Oh, you can do compile log. Nice. And I just do this. Found compile log statement. Compile log output. Wait, what is compile log? Something like this. No. Wait, why is it like saying this as shit? I don't want that, right? I see that there is a name in the end, but like, can I not disable this as struct? Oh wait, is this the full name of it? Is this the full name of the type? Okay. Maybe. That's what it is. So we have like, so we have this struct. But then I have it as. What will I write on my language? Games is the idea. But everything. Games is probably like too far in the future. We have the bot, the Twitch bot, which is already partially written in the language, so it's OOP? No, it's not OOP. It's OP, not OOP. Why is this like 3 S's? So like, I think what happens, so you know, like we have this original struct, then we convert this struct into T, and then we convert it into TT. So if I go through just T and not TT, then we will only have a single S instead of 2 S's. No, no, that's wrong. I guessed wrong. Maybe I need to print string. Zeg print. Or like, you mean compile log? Hold on. Like, hold on. Let me see this. If I do compile log hello world underscore st. Yeah, I see. Compile log output as, like, why did they do this? Why can they not just say that compile log output is hello world? Why is it as this hello world? The backprint won't work in compile time scope. I mean, we can just say we can just print. It's fine. I can do this at runtime, I guess. Std out. Std debug print. Okay. We just say std debug. Debug print this, which is type name of t. Right? That's what I do. Cannot format array without a specifier s or any. Is this, should I say s here? Yeah, there we go. So this is the name, test main struct. Okay, nice, finally. You need compile error too? Okay. Okay, so this is just the name. It's just test main struct. Yeah. Yeah, that makes sense. So basically, okay, what's the logic here then for the compiler? Like, how do I not assign it the name of t, right? Even although I assign it to a variable of name t, I don't want it to be assigned to a name t, right? Or do I? I mean, actually, in this scope, I kind of do want to report it as t. Like, it's not like super anonymous anymore. We have a name for it over here, right? So why don't we call it t here? Is it a bad thing that I'm calling it t here? Like, because that's the only name that we know it by right now over here, right? And it's something like a call chain. Yeah, but like, I mean, I'm already doing this. It's just like, the only problem is that, like, I'm just saying that this is the name t, and t exists like in the current scope, so I call it test.t, but it should, yeah, I guess, yeah, it should not be called test.t. Yeah. That's how it works in Zig. I mean, if I return the anonymous thing from the function, then yes, I will need the call chain, kind of, right? So when I call a function, I need to remember the name of the function that I called. I need to remember the arguments with which I called it, and this is part of the name of this anonymous thing that I'm returning, right? But in this case, I just don't do that because I'm not returning this type from here, right? Like, let's try this instead. What if this function foo is returning t directly, right? Function foo is instead of this is it returns type, and then I just say the return t, right? I just do this, and then if I say const abc is that, and then I say std debug print type name of abc, like I would assume that this is being assigned the name of abc now. Type name of abc. No, it's not. Actually, it's not. Wait, so what's the difference then? Is it because this over here is inside of the function? So like the local variables inside the functions, they don't have names, it's only the global ones? But what's the difference? I thought there is no difference. So if I do this over here, it will say test. Wait, hold on. It says say test abc struct 3390. Wait, what? Is struct always there? Let's say over here underscore st, and I return struct value i64. So if I return the thing that is initialized inside of this function. Oh wait, it says test foo. Yeah, it's test foo with this anonymous struct. So I have an anonymous struct as an argument here. Yeah. And this is not my name actually. Yeah, okay. Hold on. Yeah, so like this anonymous struct is being assigned a name because I call a function and I'm returning it from here. I guess I can like just, what's the logic? It kind of makes sense how it works here, I guess. But what's the actual logic? It's not just assigning to a variable. Wait, but what if I say over here? What if I say over here, I don't return t directly? What if I say const u is t, and then I return u? No, it's test abc struct. I think I know what happens in Zig. It's not at assigning, it's working differently than... so basically, they see this, const abc, and when they are compiling this, they know that they are inside the path, which is like abc, and then this is the anonymous struct, so they are assigned the name of like the current scope underscore unknown thing. Yeah. It's working differently than in my language. Then... a little bit. But can I do the same? The problem is like, do they have destructuring in Zig? Destructuring, destructured assignment, right? Do they have this, or is this an issue that is open, closed as not planned? Right. So you cannot say. Zig has basic destructuring. This is closed and not planned. What do you mean by basic destructuring? Can I have an example? Can we do... Oh, const A and const B is this? Let's see. So what if I say const A and const B is 1, 2. Expected semicolon after declaration. No, this doesn't work. Maybe just const A and B. No, this doesn't work. You're lying to me. Expected semicolon after declaration. This comma is not expected. Am I using 0? Oh, maybe I'm using the old version. You're right. Zig version. Yeah, this is I think this was 012. They don't even have the version. How do I know my version? Oh, it's just Zig version. Like this. Yeah, 012. Let's do Nix Flake update. I can download the newer version, sure. Am I downloading anything else? Oh, I'm downloading a lot of things. It's not... Yeah, this was like the OpenGL example here. Yeah, it's fine. How far did Zen go? Well, I drew a triangle on the screen. And then I stopped using Zig. Copy Nix packages into the store. Alright, fine, we'll wait a little bit. But like, my question, I guess, is... If this works, then if over here I have a struct value i32, does this struct get a name of A? So I want to print the type name of A here, right? Yeah, let's just download a gigabyte. Yeah, because I'm downloading FFmpeg. You know what? Let's just get rid of this. Flake. Let's just remove everything but Zig and Zig language server, I guess. That's the only thing that I need. Then I will download less. It still needs 200 megabytes. Wait, why so? Why am I downloading GCC? Is Zig depending on GCC? Or is that like... Or am I going to compile Zig from scratch right now? Hello, farmer. Okay, Zig version 0.14 is the latest version. I'm not trying Zig. I tried Zig before. I'm just comparing how it works because it's very similar to my language in certain ways. Let's go back like so. So I should have the new language server too. Expected semicolon after declaration. It still is complaining about it. Yeah, it's still like my Zig version is 0.14. This is still an error. Might need to be a top. This is top level though. Or maybe it must be not on the top level. Maybe it only works inside functions like this. Yes. It does not work on the top level. Okay. They are cheating. Okay. So in cast we can write anything anywhere. We cannot read. How can I not read? It 2-step said it might need to be on top. Oh, non-top level. Yeah, non-top level. Yeah, there we go. Yeah. So in cast, I'm trying to make everything being possible to be written anywhere, literally. Like, why is it like that? Like, can we not even define a function inside a function? Function type cannot have a name? What do you mean function type? So I cannot define a function here. Can I say const f is this? Is that how you do? Expected comma after initializer. What do you mean initializer? Is this how you do the function inside a function? Why can it not have a name? You have to do const func is struct f and func. Okay, I thought you only needed this if you wanted to have the like the environment, if you want to mimic closures. Because this obviously is not capturing the environment, right? That's what they don't do in Zig. Okay, weird. Nested scopes complicate the compiler and LSP server so much. Well, yeah, it's not the easy task, but like as a user of a programming language, it would make sense that I should be able to just write function foo here. Because why not? So the type name of A, by the way, if I do zig run, is going to be still test main struct. So like, yeah, because so I guess like this is the difference. On the top level, we can only have a single name in a const, and this way, this is the way that Zig is doing like the scopes with names. It already knows it because like there's only one name there anyway. You cannot do the like the destructuring here, right? Where you have like two anonymous structs. Right? You cannot do that. So it is a lot simpler because of that. So we know the name of the scope when we are already parsing the code. But I only assign the names when I am performing this pattern matching at compile time. But I can say that if so, like, like, you know, for me, everything is an expression. So like they say over here, import standard library. If inside the standard library, they already know that the library is called standard library, right? So if I say std2 here, for example, and then I will print the type name of I don't know, std array hash map. Let's have something easier. Yeah, array list in int32, right? So this doesn't mean that the name of this. Oh, they don't even say that it is std because it's like its own thing completely. Yeah. They don't even like have the path here having the std in it. Well, but I mean, the type name should have the same name. Like, if we have like this type name, then the name should be like, should the name be the same, like independently of where I'm trying to get the name of it? I guess. So I'm doing it wrong then. Because it depends. Because like the name depends on where am I using it. But there is a nice thing about it because like but it's also not exactly true. So maybe I should instead indeed do it similar. Like yeah, it's weird. Weird. But then it still is different when I'm calling a function, right? So if I have a generic like this over here, array list, right? Well, I mean, yeah, we have like the arguments to the function here, because this is when we are actually compiling that code. But I am doing it differently. I'm compiling my like my compiler is not lazy, and I'm actually compiling the code even if it's not being used. Your generics are being checked and being type checked. Same. Do you have like the naming, or do you just I mean I don't know, your like if you do the language like C, where you C++, I don't know, Rust, where you just have the explicit like namespace things, then it becomes a lot easier, right? Like if you just have mod like name, that's what we have in Rust, then you already have you already know the name of the module inside when you're like parsing this code. Like you don't, like even before you're compiling anything on the AST level, right? On the syntax level, you know it. And in C++, you also have this namespaces. The name of the module is the name of the file. Can you not have nested modules in the thing? In syntax level, it doesn't matter. Well, I mean, can you not have like the module inside a file? No, only files as module for simplicity. All right. Personally, not a fan of this. But sure. Yeah, so like I guess Zig just Zig also just actually has this on the level of syntactic level, because when they are parsing const name is a struct, then you already have parsed this, so you know the name of this struct before, because only one name can appear here anyway. And I mean, I can do the same thing technically. You might not be able to have a namespace like feature because you allow very raw string identifiers. What do you mean? If I can like have a raw identifier here, like A, B, C with a space, this is just the identifier. Like I don't know, I can have this as a part of the name, as like the namespace name. Why not? Pretty sure you can do that in Zig too. Like you literally do this in Zig. They have the same syntax for it as I have right now too. Do they do /n here too? Yeah, they do. Does my parsing care about names and scopes? I mean, well, I mean, it's not the parsing already. It's at the compiling stage, I guess. Like I can detect. Like I have let pattern be value, right? So what I can do is, if a pattern is just a single identifier, I guess if this is a const, right? If this pattern is a single identifier, then and if the value is something which is a struct, right? So like we need these two things to happen. We need the value of the assignment to be a struct, and we need the pattern to be an identifier. And only then I know, when I'm compiling this struct, that I'm inside the identifier like namespace. But that is weird, I think. Like, let's see here. If I have a function, right, which inside of its body declares another function, right? G, like this. And then I want to debug G. I don't have the names for types yet, only for functions, so that's why we're doing it with functions. So when I'm calling this function, it says that the name of the function is G, right? So, and the same would be about the type. And the reason why is because I'm assigning it to the name G. That's why. So that's the name by which I know this function, which makes sense. How do I stop users from defining identifiers that use the same notation as namespacing? What? Wait, hold on. Can you I guess you cannot have the same named variables in this language, right? You cannot have duplicate struct member name, and the reason is because it's a struct member name, right? Because I'm right now inside a struct. A module is a struct, so I cannot shadow here. I think you cannot shadow in general in Zig, can you? Yeah, that's an error too. I mean, maybe I should, yeah, I should not have that too, for like, at least like recursive scopes, where you can use something declared in the future. STD print. So maybe like my system is not that bad. I just need to do something. Like maybe I should not always assign. I just, yeah, what should the rules be though? Like it's working okay right now. For like print, I know that the name is std print. If bar symbol is mod foo function bar, is foo bar, you're allowed to have a function foo bar, some kind of collision should take place. I mean, that's not how they are stored internally, not just as strings, right? If we have a and inside of this we have a const b, And then we can also have const a dot b, right? These are different. Like a dot b and a dot b is different things, right? It's different. But maybe like if I try showing them, if I try showing the type name of AB and showing the type name of a dot b, maybe they will be shown the same. Yeah, they are shown the same, right? But that's just the printing of it. That's just the printing. Like, I'm assuming if I have a /n here, then we will also have the /n in the output here. Yes, we will, right? They're not escaping it here when it's a raw identifier like this. What's the escape sequence for like clearing the terminal? We can clear the terminal by having a variable name and like have the bell sounds and shit, right? Yeah. So when I'm calling function gbg with some anonymous type, it doesn't mean that it should have the name of this. Yes. So I think I can just at some point lose the ability at some point I should lose the ability, or maybe like maybe like for these. Down. So basically I'm just storing a function. And a function has a name. A name is being named. So like I'm just naming any value, any value, absolutely any value. Is being named. Why is there 3 E's here? So any value is just being named if when I assign it to a symbol. Well, that's wrong. That's not always something that I want. Just only in some places. This is done. When I'm interpreting code. Is that Vim again? Yeah, I'm going back and forth. So we could just have the like the scope names, right? We start the scope with the name of like the file. Then if I detect like this pattern specifically, then this scope over here is being named. Like, yeah, I could do that. But then when I call a function, then it's different. Because I want to record the function arguments as part of the thing. Not giving Helix a turn. Yeah, I don't think I will. When I'm calling a function, I should record the arguments with which the function was called. And say that this is my current scope's name. And the parent scope is the parent compiler scope in where the function was defined. But it's not always compiler scope actually. Because if a function is inside another function, then it's like that. So it's not always actually, it's not always the compiler scope that I need to get for my name. Is the feature you're thinking about making the compiler self-host or not? No. I'm just thinking about names. I have the language where everything is anonymous. So I have a struct, like in Zig, which has like the variable x defined inside. And this is a struct where field x is 0 of type int32, right? But then when I assign it to a name, like this, that's how we get a named struct. So foo should now be named. Doesn't work right now. I only have these 4 functions, but it's supposed to work for types too. And the question is how we assign, like if this is how the language works, right? We create the anonymous thing and then we assign it to a name. That's when the name is being decided. And then the generics work by having the function. So I can have foo be a generic function by having like an argument of type t, and then we return like a struct or something that has the t. I have a little special case with the for all, but it still is kind of just a function. This would be a generic one. So yeah, this is like a generic function, like so. So foo int32 should be a function. This is right now unnamed, but the name of this function should be foo int32. That's what it should be, right? Because that's what I call the function with when creating the anonymous function. So in order for this to work, let's just make this work. Let me just do this. The fact that I assign the names too much sometimes, maybe I should just think about it. So if I do this, it means that when I'm calling a function, or at least a template, I guess, I can treat them differently for the sake of naming, I guess. This would be having the name, which is that. Hold on. So we start with an unnamed thing here, right? But then when I actually return it from, so when the return happens, right? When my function here gets evaluated fully, I return the anonymous closure from this thing. At this point, I know the arguments. And I know the return thing. So I should name the return thing if needed, right? Call function. Maybe we can just do this. Yeah. This over here, instantiation, is a little bit different than just calling a function, but it's literally just calling a function. It just needs memoization, sure, which is not there yet. Should be relatively easy to do memoization though. So if a template was called, this is the result. I don't know if I should do it for normal functions. For templates makes sense. So we return result. But then I do result. This is a value. I just name it if needed as what? I think just names they are not always symbols, right? So in this case, the name is not just a symbol. The name is basically the arguments of this template, the argument over here. This thing needs to be like, yeah. Let's see this. Call if needed. The name is not always symbol. It's either we are either assigning it to a symbol or we call the function with arguments, right? So this should be something like, you know, let's do this. Name part. Let's go to name. So these are my names, right? So names is not always a symbol. This should be optional name parts. So like we only know the final part name, right? And then the name part is either a symbol, right? Or it is the instantiation, or I don't know. Let's just say like call whatever. Instantiation. Instantiation with some value. So I just literally store the value here, which I call the function with, I think. And then what is the parent name, right? Instantiation. So like argument is this, and then the parent. So for the parent, I just need to know the name, not the value, right? So I guess template name is just name. Yeah, I think I can do this. So when I display the name is basically like the list of name parts, right? And if it's a symbol, then symbol is we know in which scope it is. So this is a name part, right? So in this case, I'm going to match. And I guess parent also. Parent. Yeah, this is always about the parent scopes. But I guess it's not the scopes. Like I should know. Like, what should I know? I guess name is this. I want to know the actual name, like last part. And I want to know the parent, which is another name, right?
That's what we want. We have last part, and then we have a parent like this. So when I construct a name, I should always know the parent already. Right? Parent. I guess parent is optional. So it's like similar to scoping, but it's a little different. So parent is option. Option name. Name impl. Last part is none. Parent. When I say name if needed, I'm naming it to a symbol, but it should instead be named to a name part. So just the last part. Which I'm setting. The parent is already known. When you use object dump on C++, compile object file which had a namespace foo void bar, you see the symbol foo bar. So what's stopping someone in cast and zig transcripting a different fire foo bar? Well, I mean, isn't in C++ the name is still mangled, and then like you have the like ID in the name in the object dump too. It's not just foo bar. It's foo bar plus like the ID of the symbol or something, or at least that's how it works in Rust, right? Name if needed with the name parts. Let's just have it. Yeah, let's just have it owned. Whatever. Like this. This is the last name part. All the previous names are kind of known where we created this thing. Wait, but that is weird. That's weird. If I even know the last name part only later, then the last name part should also be known in the thing. And like it's only in the same scope. So once that scope is off, maybe that's the thing. Once the scope is like is not there, I feel like I'm doing it wrong. But yeah, instantiation would be actually calling a function. I feel like we should just be aware of the current path, right? Whenever we are compiling, when we're there, or like we're interpreting, compiling, it's the same thing, right? For me. So I should just know what is the current path that I am in. Like I should know it. And then I just assign the name to the thing when I am seeing the thing. Yeah? Right?
But this means that I will not be able to deconstruct anything here, right? I literally need this to be like parsyntactically, like before I start compiling the body of the struct. I need to know the name of the struct, which is kind of written before. Or wait a second, hold on. How can I make this work with destructuring? How can I make this work with destructuring? Like maybe this only should work for me saying like for me having like the let expressions anyway, right? So let or const pattern be value, right? So like this should be possible to be any pattern, right? But this introduces some bindings. When I'm evaluating this expression. Hold on. How would that work? Why is it so difficult? Like I'm kind of knowing all the names that the pattern is going to like all the new variables are already known at this point, right? Um, mm, maybe this is when, like, I know this expression, I have compiled this successfully. So I have compiled the pattern, I have compiled the value. And then for so like, you know, I have this expression data, which I am, so like I'm calculating something for every expression. Like I'm calculating the type, the span, the context, right? But another thing should be what name this expression should be assigned to. So like when I evaluate this, right? If this is the yeah, what is the name part here? I think that would make sense. You know, so in the expression data, I also have the Nah, it's not in the expression. It's like part of the evaluation context, because like the name part depends on when I call the thing. If it's a template, right? So the current name of the current path is part of just the this thing, right? So like it's like scope, but it's the current path, right? Current path is basically the name. And then yeah, so like we start with the name being the file name. But it's not always the file name, it depends. But yeah, let's say that it's a file name, and then every time I instantiate a template, I append to the name the instantiation arguments. Then the only problem is that when I'm creating the struct, what is the name of the struct? But I can make the name, like I can make the anonymous struct, you know, for now. Hi Ogma. I can have the anonymous struct, but then the struct actually being assigned to a name. And at that point, we like fix the path. And yeah. Okay, actually, that makes sense. Hold on. I think I know. What do I call it? Like the path. So this should be not name. It should be like path, right? Let's rename this module to path instead. Maybe like path name. Name path. It's just path, right? It's just different from standard path. Different thing. Path start. Path. Simple. Name path is supposed to be publicly re-exported here. Yeah, we already use std path, which is the problem. Can I undo now? Can I undo now? No! How do I undo? I didn't commit my previous thing. My bad. There is not much. Try if I rename this back to name. It's going to work. Fine, let's call it name. Two. And I should, like, in general, just go back here. I want to commit what I've done first. Okay, now these things, they still return paths. Name. So this over here is a to do. This is appending to the path. Name. Name if I needed name part, let's just say symbol here. name. This path is a to-do. This should be name. Works, right? No, yeah, this should be name unknown, and this should be name unknown. Unknown. How long did it take me to do all of this? We started this about 9 months ago, but I'm not working on it like every day, obviously, right? I think this is about stream number 60. So about 2 months, I guess. This was just originally a tutorial for OCaml. I was trying to learn OCaml. So, yeah. Now it's rewritten into Rust. Okay, yeah, this works. Print, yeah, this works. Okay, let me just commit this. Names. Just a small learning project? Yeah, it's just a small learning project. Okay, so now so I have this path, so right, this is current name, or like something. Since I'm calling it name, sure, let's call it name. When I'm creating the new from scratch, sure, we say that current name is name new. Oh, so like I need to provide it with the name, right? When I'm having this from scratch, I need to have the current like path so it knows about it. Yeah. So I want name here, sure. Why not? So current name is name. Name singleton with the name. How about that? Singleton. Or I guess let's just say this: name new. Name part. So we need name part. Well, I mean, I am supposed to like parse something specifically, right? Am I not? Include import. Yeah, I need to look here in the import impl. Self. Yeah, over here I'm creating a new one from scratch and everything. And I do know the name. And I know the path. You don't know anything about programming other than the word itself? Oh, okay. We just write some text and then it just does things. So maybe actually start with nothing then. That would just be weird though. I should always start with some current path. Yeah. From scratch. Let's have a name part path. I mean, shouldn't I rename this module too? I renamed it path, but I didn't rename it back. Okay, name. So we have enum name part. So it's either a symbol. So let's just have symbols right now. But symbols only be created right now with okay. Symbols are defined somewhere. But some symbols are not necessarily defined somewhere. Maybe this should just be a name, which would be just string. Or maybe like it is a symbol, because maybe the name part is defined in code and maybe it's not. If it's defined in code, we have a symbol. Otherwise, we have just a string. Or maybe it should be like, you know, file. Maybe it should be like file name. Maybe it should be file. Yeah, that makes sense, right? We just have a path buff here. Yeah, because like we start with a file, and then we have some symbols inside the files, and then we also apply some generics, right? That's what we have. So when we start, we always start a file. So just say name part, file, path. Dun, 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 dun. When I say only std syntax, this is also a thing. We should have path here, and then I pass this path directly there. When I say new normal, this should also have path, and then I say path here. But then we have the import new no std. This should also, like, we should always have path so that we know where we currently exist, right? But maybe this is just an std in, which we do sometimes too. Yeah, path. Current name new. Name new. All right, so we have a name. Once again, this is going to be a park name impl, like I was going to do. We have a struct name impl, which has the last part. I mean, this is basically like a vec of name parts, right? So, like, yeah. This is just a vec of name parts. Kind of. This thing should, I think, be clonable. Yeah, we can do it instead of a vec, because like we are making trees, right? This will make a lot of duplications. But does it actually matter? I don't know. Let's do the simple way for now. It's just like a vec of parts. So then I have a function new, the like only part is the name part, which is going to be self with the only part inside of a vec. And then we don't do name if needed. We instead say append self new part, which is name part. So this would be parts, where parts is self 0 clone back name part, and then we say parts push part, and then we do that. Because it does not deref automatically here, and you do this. So I don't do this code, and when I'm displaying the name, I'm just displaying all of the parts, right? So I just say for part in self 0 iter, just write f part, right? And then it will iterate and enumerate, I guess. And something, if index is not 0, then we write f at dot, right? Something like this. So now name part needs to implement display. And then we just say match self. It's a file. So do I just show the file? I guess we say path buff dot like file name, I guess. Returns the final component if there is one. So if let some name is file name map path to string, right? Because I want it to be a string, and we write I don't know if we do anything otherwise. And then if it is a symbol, then I just write the symbol. Type mismatch. Expected os stir found. Oh, because file name is not a path, it's the os stir. Wait, where is os? Over here. Do we have the to stir there? Yeah, we do. Okay, there we go. We'll do that. Option. Wait, what? Why is this option? Oh, it's not then. It's I need to end then. Okay, so now the function name. So now, since I'm evaluating, I just know all the current names, right? I just know all of the current names. Or do I? No, I don't. I guess like some of these name parts are like to be defined later. I guess like the final part can be defined, you know, like later, kind of name part. So it's not let's say something like to be determined, right? And that case we do mutex option name part. So like we'll know it later. Does that make sense? That's what I will do later. So I need a method, right? I need a method, public function name if needed, self. So I'm going to use like the previous thing where we are naming it with a symbol. So then I see the last part, right? So self 0 last unwrap. We always have at least one thing. So I say if let name part tbd tbd is this, then tbd let's name let tbd let tbd tbd lock wrap. If tbd is none, tbd is some symbol clone. Let's do that. Then over here, if this is a tbd, if this is a tbd, match, then I guess if let some part is a tbd wrap, then we write f else it is to be determined. I'm going to write an underscore here. Else write underscore here too in the files, because why not? So we write always something for all the parts. Why not? Overflow evaluating the requirements for phantom data sync. Consider increasing the recursion limit. Oh shit. Hold on. Cast is too powerful for us to handle. To these ones. So we don't have name unknown, right? Instead over here, we say name. I instead say cast, which is self, current name, and then I append name part tbd. Let's have the constructor for it. Full name part public function tbd self tbd new mutex new none. Sure. Overflow, we ignore this. So yeah, we just say over here is for this, we also say self current name, append name part, tbd. Right? So I know the current like path, current name of the compiler, but I don't know yet the exact name of the function or the template that I'm defining. So I say tbd here, and then when we assign it to a value, we were actually going to like have it assigned, right? From tuple value for this I guess is no longer going to be possible. This is no longer going to be possible. But I guess we just implement tuple value. This instead of from will be new, where values is a tuple values, and name is a name, right? We just have name like this, or have the name as the first argument. Oh, I have duplicate definitions. This one is no longer necessary. We just have that one. We don't do into. We instead say, oh, this is make same. Shit. Well, I can have the name to be completely unknown, I guess. Is unknown being used over here? New scope, new. Scope new. Name unknown. Sure. Function unknown. Self. This will be a self new name part tbd. Okay, so over here, what do we say? We say into. Full value new. This argument name unknown. New is private. It's not. What is this? Tuple value new. Let's say new unnamed. Function new unnamed values value self new name known. New unnamed. Overflow. Am I
Maybe once I fix the issues where there's going to be no overflow, I don't know. The tuple value is not satisfied. What is this? So yeah, this is over here. So this over here should be named. And I'm evaluating. Yeah, tuple value new result, and name should be self current name append name part TBD. I guess it's always like this. Overflow, overflow, overflow. Tuple infer value shape. Tuple value new unnamed. To do maybe named. Just have a to do here. What about this? Make same. New unnamed. Expected 2 arguments. So yeah, over here when I'm making the new one, since this over here I have a path. Path. It's a reference to it though. If this is a path buff, yeah. Okay, no function named new unnamed on the tuple. Tuple value. To do maybe named. Flow overflow. What is this? I feel like I should have a difference between anonymous and named the ones though. All right. So just the overflows are left. Is it actually overflowing the Rust compiler? My code? So what is actually happening? We have overflow evaluating the requirement for the phantom data sync. Consider increasing the recursion limit. Okay. Maybe I should just increase the recursion limit. And it's just going to work. Or is 256 still not enough? Increase it to 1 billion. Okay, actually I still, yeah, this works now. Further. This for examples. And then for main. For main over here, yeah. So like over here, I'm making cast, right? Since this is a REPL, this should be like std in, basically. Std in, because this is a REPL. If I'm running the path, then this is my path. Path. Okay. This over here is a syntax error, sure. If I try test, then this should be test. Fibonacci, just name.
Cast symbol new test Fibonacci. This should be just cast a new symbol. Span. Kind of annoying. Okay. Position 0. Like when I'm adding local thing. Yeah. File name. Test. Fibonacci. Embed cast new. Bad. Test simple cast new. Test. All right, let's go. It's going to work. It's going to work. Print. Wait, this is now lib.ks.print? Yes. Okay. So stdlib is now not named std. The file name is lib.ks, right? It's not std here now. All right. Anyway, so like there's the file name libks, and then inside of libks we have print. Sure. And then when in the interpreter I have over here, when I am calling instantiate over here, right? I just say that self name maybe I can do it always inside the colophon. Now let's just say this over here, cast or like inner or something. So inner is self clone clone, but I then say inner current name and to mutate it, right? Is inner current name append name part, and this over here is instantiation of a template. Well, I mean, I guess actually the thing is completely. So I'm instantiating the template, which means that I don't even append it to the current path, right? I get the path, which is like the name of the value, which means that this value must have a name. I mean, it is a template, which is a function, so it has a name. So the current name would actually be, yeah, this makes sense now, I think. We have template, name, and then template name is being appended with name part, but not a symbol, but instantiate with the argument. But argument needs to be cloned in this case. So we have a name part, and we have instantiate with a value, right? And then when I'm printing this over here, if I have instantiation of the value, I just write the value. No, I don't just write the value. I write the square brackets with the value because that's how we instantiate. Let's see. It maybe is going to just work now. So one of the generic functions that we have is the function parse, right? So I wonder what the compilation time is going to be when this project is actually finished. It's going to be like an hour. So I just say, so we have a function std parse, which is a template, so it's a generic function. But if I say parse int32, oh, this is a native one, so I don't get the name anymore. Yeah, okay, hold on. Should I give names to native functions too then? So that like I know what it is. I mean it's a native one, so maybe for this one I don't do it. What is it, the actual generic function that I have? Do I have generic functions that are not native? I guess dbg. dbg is done inside of cast itself, right? So std_dbg is a generic thing, and if I try to debug in 32, then this is it. Yeah, there we go. So this is std, basically dbg. I guess over here the dot is not necessary then. So yeah, the dot should not be printed if the part is so if index is not 0 and not matches part with name part instantiate. I don't want the dot there, right? You can really split it into subcrates. I already am. No, it still is like a big crate. But it's like there's a lot of what? There's a lot of async, I guess. Async? Is async very bad for like compilation? Probably is. Unless you like maybe. I don't know. std_dbg int32, just dbg32, right? There you go. Also, this has type int32, which I guess it's totally fine. And then dot underscore. Why is it dot underscore? Hold on. Yeah, so like we have this result, and the result should be named. Wait a second. No. Or yes. Yes. So the result is just named with this inner name, I think. So result name if needed. Oh, this name if needed is just to the symbol. Yeah, I kind of like want to assign the name. I don't think you have a lot of generics or macros. I mean, I do have generics. I don't know. I do have macros. I don't know if it counts like a lot though. Spare value found module name. Yeah, any proc macros? Yeah, proc macros. We do have it. Literally every function is async. Yeah, I have every function being async. But isn't that how it works when you're writing like your web servers in Rust? Do they have like huge completion time issues there? I mean, the binary itself is just 84 megabytes. It's not half of a gigabyte like my like our game, right? So name if needed. I guess I just like reassign the name instead here, or what am I doing? Like, because I'm just returning this value from, this should be just the final name of this value, right? Because that's literally what I just returned there. Or maybe like the unknown names should just not be printed. Maybe we just do this, and that's how I fix it, you know? Yep. Let's just do parts like this. So we do first true. First is false. If first and not matches, we'll write the dot. I just want to say that if let name part TBD, and if it's like not TBD, it's part, and if TBD block unwrap is none. Maybe I just continue here. I don't know. This is all cursed. Alright, it's fine, it's fine. We're going to rewrite the entire thing from scratch at some point. Right? Oh, look at this. This time it actually only took 4 seconds. What? This is the first time I can see I saw it done so quickly. So std dbg dbg int32 is this, right? Okay, now I want to there is also first is false. Why is there no dot here? There's there's dot libks. Oh wait, yeah, if not first, yeah, there we go. The other way. 4 seconds. dbg int32. So yeah, there we go. Leave ks dbg, right? So like the name of this file in the standard library is stdlib, right? But I want this to be named just std. So when I import a file, I want to say what its name is, kind of. Let's see. librs. So we have import here. That's my path. Let's have a name here. So what is the name when I'm importing something? Maybe I should import with like name be an optional string. So I will just say that name is name unwrap or path file stem. I guess just or file stem and then stem to string. Let's do that. And then we do unwrap or unknown, something like this, you know. Maybe it's unknown if it's a weird file name. I guess it's not like really a file stem. I should just say path. I think to string. And then no map. No, and then strip prefix strip suffix dot ks. File name. What am I doing here? It's a file name. And then string and then strips of x. Yeah, I'm also like doing the canonization, so it can be done like here. Okay. So this name I'm providing to the import impl. For example, the syntax should be imported with syntax, or I guess it's specifically std syntax here. And then the standard library is imported with the name std. And then when I import any other file, then we just import it with like the name being the file name. Yeah, sure. Okay, this should do it. Right, so now if I say dbg int32, this is std dbg with the int32 specifically. Okay, nice. Holy shit, it's too late for me. I should have ended the stream like 3 hours ago. Okay, so this works for functions. The type names will need to be done later, I guess. Aim for template instantiation and stuff. Yeah. Do the test still work, you think? You think I didn't break anything? Let's do test. At least the couple tests that I have, do they still work? Any second now, they're going to be run. What happened? Test mutual recursion failed, test Fibonacci failed, test ease failed. Fibonacci, why does Fibonacci not work? While compiling expected int got a reference. Wait, what? Fibonacci line 6? Oh, because the binary operator, I think I did it a little bit incorrectly, maybe. Let me see. stdlib. I did that today, right? The less than this one. Yeah. So like these functions, the binary comparison operators, they are now taking things by reference. But I think though this is how like it should be done, maybe. Oh, but previously they were going through a macro. Yeah. This is not taking the references automatically. So I need to, for all of these, let's see. So for this one, instead of mapping this syntax just to this function, we need a macro. We need a macro left-hand side and right-hand side into binary this one. Let me see how to do this. Y YT this.
I'm recording the macro here. This stuff is done so much easier in VS Code. So we call this function with left-hand side being a reference to the left-hand side, and the right-hand side being a reference to the right-hand side. Almost correct. Almost correct. The macro was almost correct. Yeah, so like if I want to compare things, then I only need references to them. I don't need to take the value, right? Macro, 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 macro. Okay, and then this just worked again, and it didn't break. I guess I can also kind of do this since this is a macro. That's what we... It's too long line now. All right, there we go. Just test. Okay, so now we have the ease test is failing. What's wrong with that? It's failing because expected something got something else. And examples is line 10. Test sum 69. Yeah. So here's the issue, right? This is where we get the problem with the syntax of the language again. I guess I'm just, yeah, like this example is right now failing, and I guess I just need to remove the syntax that I have right now. With the colons over here, macro variance, I should not be specifying the types here, and this is going to just make the tests pass again. Nice. Yeah. We need to like think maybe a little bit about that syntax. Fix the tests. And I should be done. Right, guys. Wow. Scavino is live. His game jam started today. It's been a while since I did a game jam. But sure. Covino is here. The Jiggle Jam. That's right.
Scale.
Okay. At some point, the language is going to be done.
No, on the scale Y.
And we will be able to participate in game jams with Cast, of course.
Howdy, Fowler.
That's the goal.
What's the game about? This one? Oh wait, so do we all have to make a game about your hairline?
See you guys next time.
What's wrong with my hairline?
Hairline?
There's nothing wrong with it.
Is my hairline fine? Alright, anyway. Bye.
Growing? Big? Beautiful? Jiggly? Not sure.